transportation, this is the requirement. First, integrated with other modes, as mentioned by Pak Harno before, that we need integration with other modes, especially for physical integrated, schedule, or also the payment. Second is easy to access for the terminal station. And then third is reliable. What is safe, secure, and comfortable for the passenger. And then of course the affordable tickets. We have to get ticket, lower tickets for the community or for the passengers for change to from the road transport to the rail transport. And then environmentally friendly. Finally, a healthy and clean transportation. This is all the requirement when we develop the public transportation, especially in Makassar, Makassar city. So this figure, you can see that if we make the graphs of the transport capacity and also the average speed. Usually in the urban transport, speed is low, and then we can choose which one can be applied in Makassar, whether the people mover is for small capacity and a light rail and light metro and also heavy metro. Which one technology can be applied depend on the capacity. Then the rolling stock categories we can divide by light rail transit and heavy rail. In Indonesia, we definition of the rail transit is the absolute below 11 tons, and heavy rail usually 14 or 18 tons. So light rails consist of monorail. Some years ago, the Jakarta will use a monorail, but now it's not utilization because of business. And then also AGT, automatic guided trains. You can see AGT in Soekarno-Hatta Airport, and then also train and LRT now in Jakarta LRT, and also the Palembang LRT. And then the heavy rails usually use heavy rolling stock with exclude more than 11 tons. Include metro, MRT, and or high-speed rail. This figure also, if we make a comparison distance and speed. Distance, speed, and then also the distance. If we need long distance and we need speed, of course we need high-speed transportation, high-speed rail, as now developed in Jakarta Bandung. So we suggest that policy must be taken by the government or government of central government or local government. First is to determine the share of public transportation in the city. This is first we have to define. For instance, Jakarta now the share of railway is only 2%. If we look city of Tokyo city is 80%. So it's need we have to increase the share of the railway transportation. In this case, in Makassar city also we have to determine how many percent can be changed from road transport to railway transport. Secondly, establish transportation regularity institution in various cities. For instance, in Jabodetabek, we have the BPJT, Badan Pengelola Transportasi Jakarta, only in urban area. Third is integration with public transport fares. This is very important. So the passengers only when buy one ticket can be used many public transports, as can we see in the some of the city in the abroad. Third is establishment of an efficient public transport network. We can use research how the network can be built in Makassar, which network, and then the determination of minimum service standard (SPM). For instance, punctuality, frequency of the transportation, service at terminal station, and on basis of trains. It's very important for minimum service standard because we will give the service to the passengers with these standards. And then operators who have the ability to meet SPM. This can be audit. All of the operators must be audited when the operator meet the SPM. And finally, determine transportation technology that is suitable for city condition. So this morning we talking about the railway technology. So we can make a comparison of the railway technology can be applied in city of Makassar. Finally, I would like to summarize my presentation. First is MASCA collaborate with government and private institutions to develop system, regulation, technology, industry in the operation of railway Indonesia. Second, urban transport development needs to pay attention to appropriate technology, low construction costs, low operation, and maintenance costs. This is all my presentation, moderator. Thank you very much for your attention. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much, Pak Hermanto, your presentation and the session of International Symposium. Now we would like to move to the next presenter. There is Mr. Umar Sulaiman from the representative of PT OCE. He will present the report on OCG and PT OCE about their project for the railway system development in Indonesia or in Sulawesi. Times for yours, Pak Umar, kami persilakan.
Speaker, Pak?
Sudah kedengaran suaranya Pak Umar, silakan.
Apa sudah kelihatan anunya Pak presentasenya?
Ya, sudah jelas kelihatan. Cuman
Okay, thank you very much.
slide mode. Ya, oke. Silakan Pak.
Ya, Assalamualaikum warahmatullahi wabarakatuh. Your Excellency, Rector and her representative, Vice Rector 1, Your Excellency, Dean of Engineering Faculty, thank you very much for give OCI and OCG time to participate in this event. Honorable for all experts and to all speakers and participants. Respecting to the time, I would like to share, allow me to share the activity of OCG and OCI in Indonesia. This is the second Innovation Week. This is also the second chance to OCG in the event in Engineering Faculty. In this time, I would like to share the outline of OCG profile and OCG project in Indonesia, which is ongoing project and a major project in Indonesia. And the last item is future project in Sulawesi Island. This is corporate profile from OCG. Register name is Oriental Consultant Global. Established in February 2014, capital 490 million yen. Our headquarters and number of employees as October 1st is 500 persons. OCG has overseas offices, including in Indonesia. At least 12 offices in entire the world, including India, Madagascar, and etc. Besides that, also there is a subsidiaries office which is established in each country to accommodate local engineer. In Indonesia, we named Oriental Consultant Indonesia. And I'm the person who in charge for Sulawesi. Oriental Consultant has a business in consultancy service in energy and power, port and marine, railway and mass transit, road, bridge and tunnel, urban and regional development, architecture, smart city, airport and aviation sector, and there is other sector beside above. What's the ongoing project in Indonesia doing by OCG? In Jakarta, mostly in railway sector, LRT, MRT, also Jakarta Surabaya. And there is also sewage development project. In South Sumatra, we have irrigation project, Komering irrigation project. In Java, also there is Patimbang Port development project and project management consultancy of the development of Trans-South South Java project. In Yogyakarta, we collaborate with Gajah Mada University, doing the world-class university with socio-entrepreneurial spirit. In central of Sulawesi, we have road and bridges project. Respecting to the time, we only choose six projects. This is a remarkable legacy in Indonesia. The first is Hasanuddin University development project. This is one of the special project in Sulawesi done together with OCG, funded by JICA. OCG service almost 12 years together with a very excellent lecture in Hasanuddin University. This is special because we are participate not only improving the quantity, not only improving the facility, but also we try to improve the qualitative of education and strengthening research activities in field of engineering. In this campus also we built a Center of Technology, Hasanuddin University. It will contribute to the industrial promotion in Indonesia, especially eastern part of Indonesia. We know that Hasanuddin University is one of the biggest university in eastern of Indonesia. As PMC, we participate from the beginning, which is cooperate all phases, elaborating the master plan, construction supervision, and assistant for procuring furniture and equipment. Also, we manage fellowship program. The first stage, there is 6 departments, but now become 13 departments, I think, and then later on promote to be institute of in one of institute in Makassar. I don't know the last update of this process. And then the second is Jabodetabek Urban Transportation Policy Integration. OCG also participates in around 10 years in Jabodetabek. Output of this consultancy service is detailing the Jabodetabek Urban Transportation Master Plan, enhancing capacity of urban transportation related to agency. Also, railway project in Jakarta area, as OCG continuously engaged by JICA. If there is a JICA funded, then at least there is 15 rail ongoing, and some full design and some is part designed by JICA. And other area also we have railway in Java Island. OCG also has experience in toll road and flyover since 70. We together with Oda Fund, Japanese Oda Fund, and 15 years together with government of Indonesia, developing the toll road and flyover in Jakarta. Besides the Java Island, we have also the project in Sulawesi. There is in Central and North Sulawesi province. At least there is 16 important beaches was rehabilitating so far. And after disaster of Palu, OCG participating in, we have a concept, there is a concept build back better, and OCG also including in this program. In Sumatra, there is onshore and offshore transmission as a PMC there, and then around finish the service. And one of the biggest port is Batimbang Port. Now it's ongoing project. 2018 until now is still ongoing. This is big port. Capacity container is 7,500,000 TEU per year, and car 600,000 CBU per year. And this is the future project in Sulawesi Island. We have we have pursued a smart city in Makassar. We have also the collaborate with campus engineering faculty to establish integrated coffee shop, but this one was postponed because of COVID-19. Ongoing negotiation hospital in Palu and some bridges replacement in Palu. This is the all of my presentation and introduction of OCG activity in Indonesia. And I like to say that for all engineers, all students, don't stay long in campus. Please complete your study and go to the spread the word. And I think OCG on OCA waiting for your CV. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh. Dan kembali ke Profesor Ihsan. Terima kasih banyak waktunya dan alhamdulillahirabbil alamin.
Okay, thank you, Pak Umar. Very interesting your presentation about your achievement from your company, yeah, especially in the some infrastructure and transportation infrastructure, especially in Indonesia. Now we back to the second presenter, Pak William. However, in this morning, Pak William is cannot join directly, and he is represented by Chief of Engineering Division of MRT Jakarta, Bu Weni Maulina. Times is yours, Bu Weni. Kami persilakan, Bu Weni.
Baik, terima kasih. Izin, apakah suara saya sudah terdengar, Pak?
Ya, sangat bagus, very good, Bu.
Baik, thank you very much. Good morning to all gentlemen and ladies. First of all, apologize that Pak William cannot join on this today's forum and discussion. I will represent him, and I will explain about the progress and also the technology from MRT Jakarta and the lesson learned from the phase 1 construction. Allow me to share my screen. Okay. Oh, sorry. So my screen is can be seen, ya, Pak?
Yes, the slides is clear, Bu.
Thank you, Pak.
Yeah, carry on.
So, yeah, I would like to present about the MRT Jakarta, the transforming technology for the urban society and culture. So why MRT? The 80% of the vehicles contribute to the air pollutions, especially here in Jakarta, and the 43% of emissions sourced from transportation sector estimated of 25,000 tons per year. And 31, we have the ranking of number 31 of the most congested traffic in the world year 2020 under the TomTom Traffic Index survey, and about 100 trillion rupiah loss due to the traffic that are estimated in each year. So MRT Jakarta, PT MRT Jakarta mandate is to build the infrastructure, including stations, depots, railway and trains, and also to do operation and maintenance, station, depot, railway and also trains. And the last one is we also to build and develop the business and transit-oriented development, a transit-oriented development surroundings in the station area. I would like to introduce about the MRT Jakarta Phase 1 and Phase 2 line. phase 1 line from Lebak Bulus to Bundaran HI, the corridor is Lebak Bulus to Bundaran HI, about 16 kilometers, consists of elevated and underground sections, and about 13 stations and 1 depot. About this construction will be presented in a later discussion from our colleague, Mr. Nanjo. And currently, we are also constructing the phase 2 area, the phase 2 line extension from Bundaran HI to Kota, and later on, it will be extended from Kota to Ancol Barat area. This another second phase, another section about the 5.8 kilometers length from Bundaran HI to Kota, and also about 6 kilometers additional extension line from Kota to Ancol Barat, whereby the Ancol Barat area will be the depot area located. This project is under the JICA ODA loan. About the estimated cost is about 22.5 billion rupiah until the phase 2A. And we have these features of 30 minutes travel time, especially for the phase 1 area, for about 16 kilometers, and a headway of 5 minutes headway. The targeted passengers is 65,000 passengers per day, and we also have achieved above these numbers. This commencement of the project for phase 1 is on the year 2013, and the commencement of the first operational is on March 2019. So we call MRT Jakarta as a new era of modern public transport, whereby there is also the transport integration, the integration between the Jaklingko, the Transjakarta buses, LRT Jakarta, KAI, railing, and also KAI commuter or KCI. The train itself consists of 6 cars within 118 meters, and the passenger capacity is about 1,200 until 1,800 passengers. So other than that, MRT Jakarta also looking for transforming beyond business beyond normal. First of all is beyond ridership, whereby we have this lifestyle and culture, and also the second one beyond physical mobility, where we also like to develop a digital transformation, to apply digital transformation, and also beyond transport network, whereby the urban regeneration and the growth within the Jakarta city. So as we introduced the MRT Jakarta during the operational in 2019, we also introduced a new lifestyle and culture into the city. First of all is the queuing. We have smooth and better queuing, and also the cleanliness, a 100% on-time performance. Also, we introduced the culture of standing and passing, whereby we ask the passengers to stand on line on the left side, and someone who will do a passing, they can go through the right side. And then we also introduce to use the bike. We also provide bike friendly and including for the disabilities area inside the train. And for accessibility, we have the toilet for disabled wheelchair spaces in train number 3 and 4. And we also trained our security to be friendly and also to guide them in a tactile blocks and guide them inside the trains also. Elevator areas and also braille. This is the features that we have to give the best service to the disability friends. Second of all, the beyond physical mobility, whereby this is where we put our site to the digital transformations. We have a program called the MRTJ Accelerator Program, and this program is combining us, MRT, and also the most of the startup company to get a more, with the end goal of commercializing together between MRT Jakarta and also the startup company. So the point is, the goal is that we would like to have the increase of revenue, increase of branding, and also the customer experience. The third of all is that this is also the network, beyond network provider, whereby we also provide the integrated public transportation, and we collaborate with all the transport modes in Jakarta, including Transjakarta, PT KCI, PT Kereta Api, LRT Jakarta, Railing, and also our subsidiary company, MITJ, to make new and integrated areas for public, so everyone can feel the easiness, the smoothness of the integration between transport modes. We also have this MRTJ as the urban platformer promoting digital mobility, whereby we apply a QR code in the stations and also the apps of MRT Jakarta. And also later stage, we would like to apply the account-based ticketing. So this ticketing is integrated between all transport modes, and it can be easily used using apps and also having an account-based or server-based model of payment. Next one is the transit-oriented development, whereby MRT has the TOD scheme. The MRT Jakarta has the TOD scheme between coordination between the government, MRT, and the developer, whereby the government can give the value-added area for the infrastructure, and TOD can also give the investment and area of infrastructure, rise in the property of values to the developer, to the nearby developer, and then boost the economies nearby. And also for the MRT itself, to boost the riderships, whereby we have the management fee and MRT investment infrastructure and TOD management. So we implement this TOD in the phase 1 area, including the Duku Atas area, the Bak Bulus area, and also Block M area. So come to the construction of the Jakarta MRT, especially in the MRT Jakarta phase 1, the project challenges, first of all, is land acquisition. We think this is the most challenges in every project, not only MRT Jakarta, about the land acquisitions. But of course, these land acquisitions, we can really grateful because we have the collaboration with the DKI provincial government to secure and settle the land acquisition. And the next one is the underground utilities. This is also the most big homework for us about the underground utilities. And also the permits and certifications. This is because MRT Jakarta is the first MRT and also the first project to introduce a design and build project. So the progress and procedure for the permits and certification is also challenging. And then the safety standards, we here in this condition, in the phase 1 project, we also appreciate all the contractors and also the consultants to give the best performance of the safety standards. And we can say that in the phase 1 construction, we have 0 accident, and we proceed with the best safety of standards. Coming to the second phase, some challenges like soft soil conditions in the MRT phase 2 area, especially on Tamrin area, and also land subsidence and flood threat, as we may know, especially on Jakarta in the next future. Some say that it will have a threat in floods and also land subsidence. So in this part, in the phase 2 area, we have some improvements in the design and do a better monitoring, a better standard of procedures, and also the innovation solutions are required. And then there's also the challenge of narrow corridor with a canal in the middle, and also old buildings in the close proximity. Old buildings such as heritage buildings are spreaded all along the line of the phase 2 area, phase 2 line alignment. So we have some improvements as to originally put a traffic decking and also traffic diversion plans. That is the most comprehensive assessment on the traffic diversions are required. Next one is the cultural heritage. This one is our first time of digging or constructing inside along the heritage area, whereby we require the contractor to conduct all necessary measures not to cause any damage to the cultural heritage buildings or structures based on the law number 11 year 2010 on cultural heritage. And as we goes by during the starting the digging and construction, we have found several artifacts, including porcelains and mostly porcelains, and also the latest one, there's a heritage rails. Some improvements have been made in the phase 2 area. We apply a ground penetration radar for investigating any underground utilities. We also conduct a borehole georadar test, and also to give a more stringent requirements on the flood protection system of MRT. And this, we also implement the OSV, on-site visualization, for monitoring adjacent building, especially for heritage buildings. This one we apply in the Harmony to Kota area. This is appreciate and thanks to the consultant, OCG consultant, that introduced this OSV procedure for the second phase area. The next one, our improvement is to do the digital transformation initiative and to implement the BIM, or Building Information Modeling, for the MRT Jakarta Phase 2A, whereby we see that the lesson learned from Phase 1, we need an improvement. And the vision of this application of BIM is that we have the cross-organization coordination process to become more effective, and also to avoid rework, especially to deal with the clash detection during design stage, and to do the standardized business process for all parties, including document and asset naming, enhanced traceability and interoperability of project information, and also later on to have the easy handover for asset management to the operational maintenance team, and to mitigate the construction challenges facing in phase 2 area. So this is the collaboration through the digital workflows between all parties, including the consultant and also contractors. We have several contractors, including almost 7. Everyone shall use this BIM, for the easy coordination and collaboration by using the digital platform. Some improvement features for technical wise, especially on the railway side, such as the telecommunication requirements, the PSD requirements, track work requirements, and also the rolling stock requirements. So in phase 2, we are also looking to apply and to suit the requirement from the government, especially the Ministry of Transportation. All the specifications shall be suit to that requirements. Next is the application of the railway real-time monitoring improvement, whereby we install the onboard train information system and the ground equipments or sensors to monitor train health and infrastructure status in real time, and this data can be linked to the OCC, maintenance, and other units. Not only in the railway train monitoring, but also in the infrastructure monitoring improvement, because we are transforming to the digital platform. We also apply a real-time monitoring instrument. We apply the accelerometer tilt meter and also the increase of reading frequency and sampling rate, provide smart monitoring system to direct analyze the monitoring data and automatic monitoring reading from the instruments, and also automatic notification to MRTJ key personnel to be sent to their personal device like phone or PCs when the monitoring reach the action level. Other challenges that we are facing right now is the pandemic situation, whereby in the year 2020, first when the pandemic comes and rise, we also have a going down deeply for the number of passengers. And based on that, we cater also some improvements based on the pandemic situation, like to have a more improvement in design for station facilities, compacted design with better circulation, and also behavior shaping. We can also manage to make distance for people that is coming to the stations and also trains. And also we look for the improvement of indoor air quality improvements by using the ultraviolet germicidal irradiation systems. Other than that, we are also having this kind of features: contactless ticketing system, intelligent customer service, CCTV for thermal camera, and also automated doors, automated bathroom taps, escalators and rail UV sanitizers. We are looking to considering this in the future, and to detect the crowd area. Currently, we have put some marks on the trains by using stickers to prevent people grouping and to make a disperse of distance from the passengers. So the implementation strategy, we have the short-term implementation for phase 1, which is currently procured by our O&M team. And also for the near future, the phase 2A contractors, we have provided some specifications in the phase 2 area, and also the long-term implementation for the upcoming projects. So I think that is all for today's presentation. I hope that I can give a very clear picture of how MRT Jakarta right now, and also how MRT Jakarta has improved ourselves for the better future and the better service to the public. Thank you very much.
Okay, thank you very much, Bu Weni. Very interesting, your presentation. Due to the time limit now, allow me to go to the next speaker, Mr. Daisuke Nanjo, as the project manager for MRT Jakarta North-South Line project, and we'll discuss about MRT Jakarta North-South Line project. Okay, Mr. Danjo, Daisuke Danjo, to present your material. Time and floor is yours. Kami persilahkan Nanjo-san, silakan.
Yes, good morning.
Good morning.
Selamat pagi. Ladies and gentlemen. My name is Daisuke Nanjo. I am
Mr. Nanjo. Please, may you opt for one of your account in Zoom?
Yeah. I am mental consultant. Sorry. I am mental consultant global Indonesia Daily Project Manager. Thank you very much for your inviting us to make presentation in this international symposium. I would like to make a presentation for Jakarta MRT North-South Line Phase 1 based on our experience. This is today's agenda. First of all, I would like to introduce my experience. I have experience for highway and road tunneling work construction in Japan and Taiwan high-speed rail project from 1988 to 2006. After that, I am coming to Indonesia for Java South Line double tracking project, Jabodetabek Railway Capacity Enhancement Project, Jakarta MRT North-South Line Phase 1 and Phase 2A from 2007 until now. Consulting service chronology for MRT project.
Enggak, Indonesia.
Consultant provided consulting service for MRT project from master plan, feasibility study, basic design,
Mengerti mahasiswa, makanya pintar tugas saya.
construction supervision, including operation and maintenance assistance.
Orang jago-jago semua yang
From 1990 to 2020.
ngerti kasar.
Under Japanese ODA loan, which took 30 years.
Kayak bahasa Cina ini cara apa?
Construction of MRT program was started in August 2013, and the first high-quality MRT infrastructure project was completed with Indonesia and Japanese on time in March 2019, as total duration 67 months. This is a project organization chart, which Indonesian government consists of Ministry of Finance, Bappenas, Ministry of Home Affairs, Ministry of Transportation, Ministry of Public Works. PT MRTJ as sub-implementing agency is working under Special Province DKI. JICA is lender for MRT project under Japanese government, which is coordinating with Ministry of Finance. All consultants and all contractors work together under PT MRTJ. Project outline. In the terms of the scope of service, with a total track length of 50.7 km, there are 7 elevated stations and 6 underground stations and depot and receiving substation, which is in the center of Jakarta city. Railway systems such as power, overhead catenary, signal, telecom, facility SCADA, automatic fare collection system, platform screen door, escalator elevator, and track work were designed and procured, installed. Rolling stock was also procured for 96 cars. The daily operation time is from 5:30 a.m. early morning to 12 night, and it is usually operated every 10 minutes by 6-car train, and every 5 minutes during the morning and evening commuting hour. But in the future, the system is built with a design that allows 8-car train to operate at 3 minutes interval. Construction gauge and rolling stock gauge are very important for railway project to avoid conflicting between rolling stock, structure, and facility, such as overhead catenary, signal, and telecom, and so on. Red color line is rolling stock gauge, which is required to design and manufacture rolling stock within red color line. Green color line is construction gauge, which is required to design and construct structure and facility outside of green color line. Left side is for underground section, right side is for elevated section. This is track layout and station platform arrangement. Elevated station has side platform type. Block M station only has 2 platforms and 3 tracks in order to stay rolling stock in case of emergency at the middle point of the loop. Underground station has Iceland platform type. Both terminal station, Leverkusen and Bundelheim station have scissors crossing in order to switch back the train. Technical feature of the project in elevated section, balanced cantilever construction method was introduced above JORR. Station and viaduct construction by launching gantry method was introduced above public road. 3R embankment reinforced soil retaining wall was introduced in depot at the first time in Indonesia as Japanese technology. In order to accelerate elevated station construction, tower crane was used for material loading and unloading. Technical feature of the project in underground section, high quality tunnel without water leakage was constructed. 2-meter diameter double water pipe hanging protection method was introduced above underground station. Underpinning method was introduced in order to construct box culvert or tunnel under Pemda statue with 70-meter height. Underground construction by top-down method was introduced. These pictures are shown various railway system and track work components such as substation, track work, overhead catenary system, signal, telecommunication system, operation control center, automatic fare collection system, ticket vending machine, platform screen door, and maintenance equipment. Contract terms. All civil contractor contracts were referred to PDP year over. Railway system, track work, and rolling stock contractor refer to PDP silver. All contractors had responsibility for design and construction. Consultant was named as the engineer in civil contract. We were named as the employer's representative in railway system, track work, and rolling stock contract. Consultant had responsibility for design review and construction supervision. There is a major difference between yellow book and silver book. In the event of unforeseen physical condition, the contractor are entitled to receive reimbursement of additional cost. However, this belongs to railway system and track work rolling stock contractor. Construction management consultant organization chart consists of 6 groups. Project management group at construction management expert, railway system integration expert, QA/QC, safety expert, and contract expert. Elevated construction group at resident engineer and elevated expert. Underground construction group at resident engineer and tunnel cut and cover expert. Civil architecture and MVP group had design review expert. Railway system group had various railway expert and rolling stock group had rolling stock expert. Total employee was 172 people, including forging expert and Indonesian engineer and inspector. Construction management consulting service task. Consulting service was named as Construction Management Consulting Service in accordance with contract with PTMRTJ. The management task cover various elements such as design review, schedule control, cost management, contractor administration, quality control, safety control, interface coordination, traffic management, environmental control, risk management, and authority coordination, which requires a consultant extensive design build and EPC turnkey project experience and capability. The design review. Contractor design consists of inception design, technical design, construction design, and as-built document, which is required to review contractor design by the consultant in accordance with employer's requirement. Contractor established and implemented design quality plan, and then contractor made design condition based on employer's requirement. Contractor designer made calculation and drawing with certificate. After that, contractor requests third party to review design and issue certificate. Consultant review all these processes based on the employer requirement. Project management system. The consultant established project management system for 8 contract packages, including an overall implementation program, project communication plan, project coordination plan, and project monitoring system, in order to ensure the project delivery within the scope, quality, time, budget, functionality, and reliability as planned and developed in the project contingency plan, which contain all of the necessary steps, system, and process to be followed by all parties involved in the project. Authority coordination. Before construction, it is required to acquire land or MRT structure and relocate or demolish utility, facility, tree, and so on, because of conflicting with MRT structure. Consultant supported coordination with related authority for land acquisition, utility relocation, transient bus shelter relocation, traffic management, cutting tree, pedestrian bridge location, drainage location, and road widening before construction. Interface coordination. The consultant supported interface coordination for 8 contract packages for the design and construction, including schedule adjustment, in order to manage all of the elements and components in accordance with employer's requirement at all stages of the project life cycle. Yellow color is provided by civil contractors such as depot, elevated station, underground station, and tunnel. Green color is provided by truck work contractor, depot, elevated section, underground station, tunnel. Black color is provided by railway system contractor such as overhead catenary, substation, signal telecom, escalator, elevator. Pink color is provided by rolling stock contractor. Cost management and contract administration. After commencement of the project, claims were increased gradually due to a delay in land acquisition, utility location, uncharted utility, design chain, acceleration. Consultant perform an evaluation on total 395 variation and query, including time extension request, based on the contract, and successfully solved all of them within 9 months after completion of the project. Taking over. The consultant established taking over committee with employer and all contractor. Contractor prepare documentation such as QA/QC document, warranty, certificate issued by authority, and as-built document, and then contractor apply necessary document with attachment before 28 days of assurance of taking over. Consultant perform final inspection for taking over with all contractor and employer in order to ensure the work were actually completed. When all parties agree on result of inspection with condition, taking over certificate were issued by the consultant to all contractors. After completion of the project, consultant supported for authority inspection in order to obtain certificate and permit smoothly before commercial train operation. Building permit, railway infrastructure safety certificate, telecommunication system permit, receiving substation permit, cable route for receiving substation permit, electrical power installation, operational certificate, escalator elevator permit, rolling stock safety certificate, and license. After obtaining necessary permit and certificate for each item, MRTJ obtained for railway infrastructure permit and commercial train operation permit from governor of DKI before commencement of the commercial train operation. First successful MRT project in Indonesia, tunnel groundbreaking ceremony with Indonesian President in February 2016, site visit with MRTJ President and Japan Ministry of Foreign Affairs in July 2018. Site visit with MRTJ President and Japan Ministry of Land, Infrastructure, Transport and Tourism in December 2018. MRT North-South Line Phase 1 project was achieved for commercial train operation target in March 2019, which is contributed for economy and society between Indonesia and Japan. MRT project has been received prestigious award from Japan Society of Civil Engineering for Outstanding Civil Engineering Achievement Award in 2020 and FIDIC Project Award in 2021, which recognized internationally for MRT project. OCG received fourth Japan Construction International Award from Ministry of Land, Infrastructure, Transportation and Tourism in Japan in 2021. And I also received Outstanding International Infrastructure Engineer Award from Ministry of Land, Infrastructure, Transportation and Tourism in Japan in 2021 as I joined in MRT project. Thank you for your support and assistance for MRT project and for the success of the project and for the many prestigious awards for its success. OCG is providing construction management consulting service for MRT Phase 2A since June 2020. Phase 2A consists of CP201, CP202, CP203 as civil underground package and also railway system package. OCG would like to support MRTJ to achieve project target on time. Thank you very much for your attention.
Okay, thank you very much, Mr. Daisuke Nanjo.
Yes.
Well, ladies and gentlemen, now we are come to the question and answer session. If there are any question, please raise your hand or comment on chat, and don't forget to mention your name. Don't forget to mention your name. For first, maybe 3 questions is enough, and we'll continue the next question after the speaker answer. Okay, please, if there is a comment or question from the all participants. Ada pertanyaan?
Ada yang raise hand? Ada? Oke. Mungkin kalau tidak ada Pak Isra. Ya. Bisa? Tes 1, kedengaran suaranya?
Ya, silakan
Ya.
Pak Ilham
Ya.
from Faculty of Engineering,
Yes.
Sanudin University.
Yes, thank you. Good morning, everyone. Thank you for this opportunity. This is actually a very good opportunity for us to have information related to the potential of and possibility that in the future we also can implement MRT, specifically in the Metro Makassar. That's why in the second session later, we will also have a discussion related to, more specific to the light railway. But for this first session, we basically discuss the possibility of making this MRT in a broader conditions. So I would like to address my questions to some of the speakers, especially Bapak Dirjen yang tadi diwakili oleh Bapak Direktur Infrastruktur ya, tapi kayaknya Pak Harno sudah tidak di tempat. Maybe this question will be responded by Pak Ferdian from LRT Jakarta. My questions basically more on the possibility of looking at this prospect on the broader South Sulawesi, because I know some of the spatial planning has been discussed or maybe planned that there will be railway from Makassar also to the southern part of South Sulawesi. And I believe even some kabupaten, ya, beberapa kabupaten itu dalam RT/RW in their spatial planning for the 30-year span already trying to put the existence, the possible existence of this railway. So my question maybe to others as well, baik itu ke Pak yang mewakili Pak Direktur Infrastruktur, saya lihat Pak Hermanto juga masih ada dari masyarakat perkeretaapian, if he wants to respond to these questions. Basically my question is how we can see specifically on the potential of South Sulawesi and the city of Makassar that this can be implemented. Or maybe probably if we want to put it more projection, kapan kira-kira? Ya, apakah saya akan menunggu dari jumlah populasi kota Makassar yang later on will be continually develop, increasing of course, or there might be other events, ya, atau momen barangkali, karena if the development in Indonesia continues focusing on construction, for example roads and railway, how it can be connected to each other in terms of mode of transportation, this can be to apply or occupy, utilize the technology. Karena I believe that this technology can still be built without having to wait until we are ready, basically, like that. So that's all, Pak Moderator. Basically, if that can be answer for all the speakers, that will be good. Pak Nanjo is a very nice, Mr. Nanjo, it's a very nice and detailed presentation of this MRT Jakarta. So basically, that's my question. If can that be asked by all speakers, that will be good. Pak Moderator, I return back to you. Thank you.
Okay, thank you, Pak Ilham, for your appreciation to all of the speakers and your question addressed to any speaker can be answer your question related to the potentially of the Makassar or Sulawesi region related to the implementation of the railway system, particularly for urban area, yeah. And the question is about how our special planning for the implementation of the railway system. Okay, if there is no another.
There is a question in the chat.
Oh, but very general, I think, about the regeneration, about the young engineer. Okay, please Pak Harno, jika masih ada di tempat atau yang mewakili Pak Ferdian, ya, kami persilakan, dan kalau sempat Pak Hermanto can answer Pak Ilham question. Kami persilakan Pak Ferdian, please.
Okay, thank you very much, Mr. Chairman. Everyone who are still in the meeting. So forgive me if I do not have a very good English, but I will try to explain in English due to the reason because almost all of the parties here are which involved in this particular event is not only from Indonesia. So perhaps I would like to put it this way. The government duty is to prepare and to provide the same service for all citizens, which means that of course, that the railway is also one of the services that we need to provide as a transportation, one of the transportation mode, mass transportation mode that could be used for all citizens, especially if we're talking about the Sulawesi. So the plan is for Sulawesi Railway started in 2014, which is the president order for us to build for the Trans-Sulawesi. The first phase is, of course, the Makassar Parepare, as everyone already, perhaps everyone is already know regarding this, which is basically in the future we have a big plan to build the railway in Sulawesi until Manado Bitung, which we hope that we could, we could make some kind of an integration between all of the from the north until the south, yeah. In the recent event, due to some reasons, yes, the development is not as fast as we predicted in the very first beginning, but I think this is still the plan that we are going to apply in the Sulawesi Railway. So, other than that, we also have a plan to build, let's just say, some kind of a commuter railway line in the big city in Indonesia. This is our still very, let's just say, still preliminary plan that we are going to implement. Let's hope that within the near future that we could make this preliminary plan to become existence, and then after that we start to build the railway, not just in Jakarta, not just in Java Island, not just in Sumatra Island, but also in other islands, such as Sulawesi, Kalimantan, and Papua. Since that we also have Mr. Hermanto as chairman from MASCA, which basically are the one who, let's just say, started this plan in the very first beginning regarding the whole Indonesian plan. I still remember Mr. Hermanto ordered me to, when I was still working at the previous office, which is basically that I was the one who are in charge of supply giving the supply of rails and turnouts for all the railway line in Indonesia. One of the example is also the Makassar Parepare railway line. He ordered me to one specific things. Mr. Ferdian, we are going to build the railway starting from now in all of Indonesia. So I think Mr. Hermanto will be, we could give us a better explanation regarding the plan, and then after that, what is the implementation? Thank you very much for now regarding the question from Mr. Rehan. That's it that I could answer. Thank you, sir.
Thank you, Pak Ferdian.
Okay, thank you, Pak Ferdian. Pak Hermanto, silakan if you have any.
Okay. Yes, thank you, Pak Ferdian, and also moderators. Sorry. Regarding the urban transport in Makassar, I would like to give some of information. First, as I know that we already have the study some years ago by the Unhas, I think, and Makassar local government. There are 7 lines already indicated in Makassar. They study years ago, and I hope that we have to make a review study for the new condition now. This one, and then the second one is the problem how to implement this development, especially in the urban transportation. First is budget. Which budget can be applied, whether the government budget or private. As I mentioned in the presentation, that usually for the urban transport financed by the government, because it's not it is very high investment and also not profit. And the second thing, besides budget, is the land acquisition. The problem in Jakarta, land acquisition is not very much, because LRT, we use the road and also the toll route. So that's why we do not have many land acquisition. I don't know in Makassar we still have the land or not, because if we have land, I think we can start. So and the third thing is the benefit of the development if we develop the railway in Makassar. For instance, the benefit and for the economics, especially for the environment. Yeah, so we can save from the road transportation to the railways. It means that we can make environment friendly. The third thing is, the fourth thing is, which technology can be applied? LRT, train, LRT, MRT, or other things. So if we have learned with Jakarta, I think LRT is enough from Makassar, because of the land acquisition we need, and then also the scope of the region. If we develop MRT like Jakarta, so we need more budget, because if we at the undergrounds, we have many budget for to invest. So if we can propose that whether LRT or MRT, but we use elevated tracks, not underground or not at grids. That's all my answer, Pak Isran. Thank you very much.
Okay, thank you, Pak Hermanto. we move to the next question. There are questions in the chat room in the Zoom application from Mr. Herbin Beta Ubun, the lecturer of Musamus University di Papua, di Merauke. His question about land acquisition. The land acquisition is the most difficult challenge in all projects, especially in railway system project. I just want to ask, what is your opinion in completing land acquisition in this country? Very general, the question, but very important and significant. The essential of the question, yaitu about the land acquisition. Yeah. Okay, please, Pak Ferdian, Pak Hermanto, and Bu Weni, and then Pak Nanjo. If you have a comment about this question, please, times for yours. Kita ke Pak Ferdian dulu, silakan Pak Ferdian, ini pembebasan lahan ini, land acquisition.
Baik Pak, pertanyaannya tricky ini, sulit juga ini dijawab. Okay, so land acquisition is it's a quite tricky way. Well, let me just put it this way: that of course that we have a standard to make a land acquisition in this country, which basically will of course we have to depend on BPN, for example, and we have to depend on appraisal to get the price and things like that. But one of the things that we need to remember during the land acquisition is not only regarding technical issue, but we also have to think about how we are going to face the society, or how we are going to let's just say that there is a social side of this, and this is one of the tricky things, because when we discuss regarding social, means that we need to understand also what is the society, or what is the especially the people who are let's say have to give their land to be bought by the government, and what is their opinion regarding, let's say, the price and things like that. Now this is quite difficult because of the price. Usually we are depending on the result of the price, and then during the negotiation process, of course, if the price, especially there is already a standard in which I think in each area which the price of the land itself, but then we need to remember back again to the social part of the negotiation process. So but I think Indonesian citizens now are realizing that in order to have a bigger impact for our country, sometimes we need to lose some to gain some. This is something that we need to educate the citizen, educate the people of Indonesia, that it's not all about getting profit out of something or out of project, but it's about giving something to your country in order for us to reach a higher level in the future. But I think based on the experience in LRT Jabodebek project that we have experienced together, unfortunately Mr. Fadli, the PPK for the land acquisition, cannot join us today. Based on that experience, I think that we already have a very good system which includes all of the parties involved in the land acquisition. And even though that we have some, let's say, some things to settle on, we could settle on court, but not without, it's not about going on court doesn't mean bad, doesn't mean a negative way. It's sometimes it's a positive way also to settle things. So in the future, I hope that the people of Indonesia start to realize that we do have a big job to do in the future. We do have a big responsibility to give the best for the people, for all of the Indonesian citizens. So Yeah, land acquisition it's a tricky part, but I think we can solve it in future. I don't have any particular answer for this, but if someone wanted to discuss furthermore regarding the land acquisition, the detail of the land acquisition that we do in LR Jabodetabek, please be free to contact us, and we will inform you furthermore regarding how the land acquisition is being done in LR Jabodetabek. That's it, Mr. Chairman, for me. Thank you very much.
Okay, thank you. The answer of Pak Ferdian. Kami persilakan Pak Hermanto kalau if you have any answer about
Yes,
the
thank you very
related
much,
to the
Pak.
question.
So regarding the question from Pak Herbin about the how to solve the land acquisition. So I mean, in my opinions, there are three parts. First is use the technology. I mean the railway technology that minimalize use of using land. First, we can use the routes like in Jakarta and also in Palembang. And then the second is we use the elevated track, whether LRT or MRT, depend on the demand. And then the second thing is, of course, budget. Budget for land acquisition is not low, but we have to maybe government can be finance this budget. And the third thing is socialization to the community. Socialization about what is the beneficial of the railway development in this area, as can be used by the passengers. So this socialization we use and when we land acquisition for Makassar Parepare with last time with the local government Sulawesi Selatan. This is my opinion, Pak Isran, for the land acquisition. Thank you very much.
Okay, thank you, Pak Hermanto. Bu Weni Maulina, if you have opinion about this, your experience about the land acquisition for MRT development project. Silakan,
thank you,
Bu.
Mr. Chairman. So, thank you, Pak Herbin, for the question. And yes, it is a very interesting part, for land acquisitions. And I fully agree with both explanations from Pak Ferdian and also Pak Hermanto. First of all, is that social assessment or social impact is something that is necessary to be done before we conduct the land acquisition process. And a lesson learned from phase 1, where we use the JICA ODA loan, and JICA requires a JICA environmental study, including the social assessment for social impact to the project affected people. So this is something that is necessary to be done first thing before the project starts. And also in the MRT project, we conduct based on the law number 2, 2012, pengadaan tanah untuk kepentingan publik. So we are using those laws for number 2 for 2012, especially when we start the railway project. It's actually the strategic project. Usually it's a strategic project, a public project. So we can use this land acquisition law number 2. And some approach also in MRT Jakarta, we have some kind of public consultation. During those public consultations, sometimes we can give or hear some feedbacks from the project affected people. Usually they will say some objections, and then we can also give a mediation on how our design or our alignment can be changed. But of course, railway alignment is difficult to be changed. Yeah, so I fully agree also with Pak Hermanto. If we can secure some right of way at the very beginning, it will be benefit for us using the roads. We can secure the alignment based on that. But then when it comes to entrances, depots, yeah, especially for entrances, this kind of entrances can be how to say mediate with the landowner. That is what we are going through in our phase 1 and also phase 2 project, Pak.
Oke, terima kasih Bu. Pak Nanjo, Mr. Nanjo, you have opinion about the land acquisition problem in the MRT project? Pak Nanjo, apa masih you still here? Okay, we move to the next question. There are questions in the chat-in room from.
Elevated section also entrance.
Okay, please.
And some location we could not construct in advance because of land issue. Especially Leverkusen, bus terminal and soccer stadium. This land, it took more than 2 years. So this is also government land. So maybe we'd like to recommend to establish a land acquisition committee in advance. And also socialization is required quickly. Thank you very much.
Pak Gunadi mempertanyakan frekuensi penggunaan daripada pelaksanaan OCS monitoring and rail grading work that presented by MRT Jakarta, and also around the other question, around 40% of MRT Jakarta operation area are underground. And this considered as a confined space. Confined space requires special attention with regard to safety, especially fire safety and guard ventilation. How is MRT Jakarta is dealing with this? Thank you. Okay, there are two main questions from Mr. Yasa Gunadi. Kami persilakan dari MRT, Bu.
Baik.
Silakan Bu. Bu Weni.
Ya, baik Pak. Terima kasih. Sorry, I will answer the second question first about the confined space and the underground station. Yes. This is during the first basic engineering design at the time was conducted by Ministry of Transportation. At that time, we conclude that we will use the Japanese standard or Japanese guideline for the underground fire safety and also ventilations. So this is also one of the challenge in phase 1 because until now we do not have such standards in Indonesia for the fire safety and ventilations for underground stations, yeah, stations and tunnels. So we follow the Japanese standard. So principally, for the fire safety, we are using from tunnel to tunnel, we are using the ventilation shafts. So there will be a ventilation shafts on each stations, 2 sides. And then for the fire safety, principally we are following a Japanese standard whereby there is a non-fire material ya Pak. Jadi material yang digunakan itu tidak boleh terbakar sebetulnya, tidak boleh cepat terbakar. So we are using that kind of specifications. So in Japanese standard, they say that they are having a zero accident or zero tolerance of the safety standard. So there should be no fire inside the stations, and then people will be evacuated outside in several minutes. Usually we are using 5 to 8 minutes for people to evacuate to outside. But this kind of standards, because it was adopted from Japanese, currently we are also collaborating with the Dinas Pemadam Kebakaran in DKI Jakarta to gather and to build up a new specifications specifically for fire safety and tunnel in the Indonesia area or in Jakarta area. We have to combine with our culture also because Japanese culture and Japanese environment is different with Indonesia. So that is for yes, there is a special attention for fire safety and ventilation. Second of all, on the OCS, the frequency of the monitoring is about monthly. Also for rail grinding, it's also around monthly until 3 months checking back. And what measures the triggers for the replacement of OCS equipment is the contact wire. Usually the contact wire is the first that is having the cepat aus ya Pak ya. Jadi the contact wires is the one that is having more wear and tear intensively. So contact wire is the most important thing that we need to check.
Terima kasih Bu. Ya. Jadi maaf saya jawab ya, tanya lagi. Jadi tadi saya lihat pakai kamera ya Bu ya. Jadi kameranya di record segala macam ya. Ya baik. Kemudian terima kasih Bu. Kemudian ini saya mengenai yang kebakaran. Jadi seperti saya pernah baca tuh di terowongan Inggris dulu di Channel Tunnel itu ya pernah kebakaran 2 kali kalau nggak salah. Itu evakuasinya gimana ya Bu? Itu aja. Terima kasih.
Ya. Maybe for tunnel part, Pak. That's why in Japanese philosophy of design standard, we need to see where is the sumber ya, where is the base that is getting the fire at first. Usually it is in the train. Now, once the train get caught fire, the train needs to coast to the nearby station, Pak. So it needs to get to the nearby station. Dan di dalam train pun ada, di dalam kereta pun ada APAR gitu ya. Jadi ada penanganan pertama. Tapi train harus berhenti. Train needs to stop on the nearby station, and then the passenger will be evacuated to the station. Now the station will be the safe haven. We call it the safe haven. Jadi titik sumber apinya memang harus dicari gitu Pak.
Baik, terima kasih Bu. Jadi saya mau naik MRT lagi sekarang. Terima kasih.
Baik Pak.
Thank you, Bu Weni. Mr. Najo, if you have any answer about the question, please.
Explains enough. Yeah, thank you very much.
Ada? Okay. Okay, ladies and gentlemen, we finally come to the end of the first session. Before we close the session, I would like to thank the speaker for the informative and interesting presentation, and to all the participants for the very active participation. Finally, give the applause for the speaker and for you all. As additionally information, for the session 2 will start at the 1 p.m. Kita start kembali pukul 1. Hope all of us may stay tuned. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Terima kasih Pak. Thank you.
Pak Moderator, jam 1 Jakarta Pak, jam 1 ini Makassar.
Jam 1 apa Panitia? OC jam 1 Makassar Pak.
Oh ya, breaknya sampai jam 1 Wita Pak.
Wita.
Jam 1
ya,
Pak.
ya.
Pak Jumardi, jam 1 Pak.
Oke. Terima kasih.
Kita break dulu makan siang, salat Pak. Mana MC? Masuk dulu siapa? Apa lagi? Gak bisa ya? Oke, I'll take over. No problem. Sudah? Belum bisa masuk ya? Baik. Bapak Ibu yang saya hormati, itu tadi dari Bapak Moderator sesi pertama ya. Insya Allah bahan materi persentase dan absensi, tolong absensinya bisa diisi dan bahan persentase akan dikirim ke alamat email oleh panitia. Itu sedikit informasi dari panitia, dan sepertinya kita sudah bisa istirahat sampai jam 1 Pak, Bapak Ibu. Kita akan istirahat makan siang dan sholat. Insya Allah pas jam 1 kita akan mulai sesi kedua, dan sesi kedua akan dimoderatori oleh Bapak Insinyur Habibi dari SMAC International. So please tune in. Roomnya kita tidak tutup, silakan aja terbuka dan supaya tidak keluar masuk. Demikian barangkali informasi dari panitia. Bapak Ibu, terima kasih atas kehadirannya. Kita akan ketemu di sesi kedua nanti.
pasti begitu Pak. Itu yang
and a very warm welcome to the Department of Mechanical Engineering at Hasanuddin University, Indonesia. Standing as one of the oldest departments at Unhas, the Department of Mechanical Engineering was first established on 10 September 1960. It has a long-standing history of providing quality education, with curriculum that offers a strong foundation for students to excel in their careers and ready to compete globally. This department has obtained the National Accreditation Status, rank A, the highest based on the decision of the National Accreditation Board for Higher Education. With our new campus located at Goa, our students are allowed to have space, fresh air, and the feel of a beautiful atmosphere. The new campus is a wonderful learning environment with dedicated indoor and outdoor learning spaces. As well as technology development through the Center of Technology, that instill a love of learning in our students and encourage curiosity. Teaching and learning is at the very heart of what we do as a department. Our vision is to develop an excellent program in obtaining mechanical engineers that capable in research, development of science, technology, and art on energy conversion, mechanical construction, and metallurgy. Our program comprises of 149 of semester credit points with duration of the program in 4 years or 8 semesters. A major part of our teaching and learning activities is focused on student-centered learning and laboratory-based education. With the help of total 30 highly qualified academic staff, the diverse range of teaching methods are used for different learning outcome and context, and none of the courses are acquired exclusively by one method. The learning process is also supported by total 11 well-equipped laboratories, a workshop arena, and 3 laboratories as research laboratories to support the final project. These laboratories support the fundamental theory taught in the classroom. Each laboratory is completed with practicum models, and at each practicum, standard operation procedure has also been established for each laboratory. Other than those laboratories, the department building is also equipped with comfortable classrooms. The department assistance room, which used for consulting assignment from lecturers to students. The Students' Association Room for discussions and meetings between students. The Department Office, which used for consultation and assistance. And Internet facilities to support academic interactions. Theaters and computer lab are also available at the faculty building. As a part of UNHAS, one of the largest autonomous university in Indonesia, of mechanical engineering can also access tremendous range of other facilities in the main campus. The facilities include libraries, University Sports Center, and University Hospital. Finally, our department will continue to actively support mechanical development and innovation to meet numerous goals, including the needs of society.
Check mic.
Check mic.
Check. Check mic. Check mic.
Bapak Insinyur Habibie Razak, IPU APEC Engineering ya. Jadi beliau khusus datang dari Jakarta menghadiri International Symposium kita ini, tentu dengan dukungan beliau di SMAC International. Adinda, saya biasa manggil beliau ini Adinda, tetapi beliau termasuk salah satu pentolan dari PI ya. Kemudian juga alumni teknik sipil ya. Jadi beliau cukup berkarir sekarang di SMAC International. Jadi ini salah satu support dari perusahaan yang berkolaborasi dengan OCG untuk mensupport International Symposium kita ini. Baik, untuk menyingkat waktu Pak Habibie, kita persilakan untuk memoderatori sesi kedua.
Suara nggak kedengaran, masih di mute.
Oh, masih di mute. Suara saya kedengaran? Halo.
Belum.
Cek 1 2. Cek.
1 2.
Kedengaran nih Kak?
Sudah.
Oke.
Suara saya sudah
kedengaran. Tuh ancanan kan.
Halo. Kedengaran suara saya?
Sudah jelas.
Tapi dia menggema. Sudah saya mute ini. Ini bisa? Hah? Pakai mic ini enggak kedengaran? Iya. Tes 1.
Nah, sekarang nggak ada suaranya.
Sebentar Pak Jumardi. Suara saya kedengaran?
Iya Pak, kedengaran Pak.
Tes 1 2. Pak Habibie
Kedengaran Pak.
Tapi kecil.
Sudah.
Kecil di sini, tapi saya lihat Pak Ilham malah tanda mic-nya masih di itu, yang merah kan?
Kalau saya pakai ini menggaung Pak di ruangan. Makanya saya matikan.
Soalnya jadi satu itu Pak, satu ruangan kayaknya itu berdua.
Halo. Sudah bisa? Kalau saya pakai ini saja menggema ya? Tak bagus. Hah?
Menggema.
Tapi kalau saya buka mic ini nggak sudah kedengaran?
Kedengaran Pak.
Oke. Ya. Baik. Ini sudah nyala juga. Sudah bisa Mayang? Tes 1 2. Pakai mic ini ya. Sudah enggak menggema toh?
Masih Pak.
Mas.
Okay, thank you. So, can you hear me clearly? My voice is clear? Should be clear ya. Udah clear ya, Dek. Oke, thank you.
Silakan.
professionals, ladies and gentlemen. Now we are moving to the afternoon session for this international symposium on railway technology and development, organized by Faculty of Engineering, Hasanuddin University. It's actually the second EPI Innovation Week in this year 2021. As we have so many speakers in the afternoon session, then we try to maximize our time allocation. So every speakers can have their 30 minutes presentation session. And later on, after all the speakers completed the presentation, we are going to move to questions and answer session. Okay, let me introduce our speaker this afternoon session. I think the first speaker will be Mr. Mitsukage Yamada. Mr. Mitsukage is the Deputy General Manager, Global Environment and Smart City Department, OCG. And the second speaker will be the Mayor of Makassar City, Bapak Insinyur Muhammad Ramdan Pomanto. The third speaker, hopefully, will be Pak Insinyur Yomil Rafianda, yeah, from Wijaya Karya Beton. He's currently in charge as overseas marketing manager. The fourth speaker, Pak Jumardi, yeah. Pak Jumardi currently assigned as a head of Railway Bureau of South Sulawesi. And then the fifth and the sixth presentation will be delivered by my colleague, actually my supervisor, Ibu Karen Atkinson, is Deputy CEO ASEAN and Regional Manager Indonesia for SMAC International. And the last speaker will be Mr. Saf Del Aquila, who is currently based in Australia. He's our SMAC Principal Project Manager for Sydney Northwest Metro Project. SMAC in Australia, yeah. Okay, let's start with the first speaker. If we have Yamada-san available for the first speech, time is yours.
Okay, thank you for your introduction. Selamat siang, nama saya Yamada dari Oriental Consultant Global. Terima kasih atas conference hari ini. Thank you for your joining my presentation. I'm very happy to be here to give my presentation. And thank you for all in Hasanuddin University. And happy 61st anniversary of the Faculty of Engineering. So today's conference theme is Railway Technology and Development, but my topic today is slightly different. My topic is digitalization in the renewable energy. Of course, the railway uses energy, and decarbonization has to come to the transportation domain as well as the other technology domain. So let's start my presentation. Before entering the topic, let me introduce my company. My company is Oriental Consultants Global, or OC Global for short. OC Global has over 60 years of experience, almost same experiences as the Faculty of Engineering. Number of employees around 500. We have delivered over 3,000 projects in over 150 countries. We have several offices in many countries, and we have a Jakarta office in Indonesia. OC Global work in a lot of sectors such as airports and aviation, agriculture and forestry, architecture, renewable energy, and so on. Of course, railways and mass transit is also the OC Global's work. Out of these sectors, I want to introduce some of our renewable energy projects and smart city projects. The first one is a feasibility study for finding potential areas for renewable energy project in Ibai Island and the outer islands of the Republic of Marshall Islands. In this project, OC Global played a role of the preliminary design of microgrids and renewable energy system for small islands. The second one is an introduction of solar system in Georgia. In this project, OC Global introduced total about 700 kilowatt solar power system in the international airport and a university. The third one is an introduction of solar system in Egypt. In this project, OC Global surveyed, planned, and designed the solar power system in Egypt Japan University of Science and Technology. The fourth one is a program to facilitate private sector-led promotion of low-carbon technology in Saudi Arabia. In this project, OC Global played a role of feasibility study of solar power system, battery energy storage system, and energy management system as additional equipments to the existing wind power generation. The feasibility study has just completed in this summer, and the demonstration project soon will start if the result of the feasibility study review by a committee of external experts is positive. The last example of project is a huge smart city project named NEOM in the Kingdom of Saudi Arabia. In the initial study phase of Saudi Arabia's smart city project NEOM, which is attracting attention as a state-of-the-art, a giant development project. In this project, OC Global conducted a preparatory study on land use, infrastructure, mobility, smart technology utilization, and etc., and contributed to the framework of development of the current master plan. After finishing our company's introduction, then I will go on to the main topic today, digitalization. Recently, the digital transformation, in other words, DX, is a topic every day, everywhere. But here today, I will present the digital I will not present the digital transformation. Someone may think that the digital transformation and the digitalization are the same, and someone may not. I will present the digitalization of the energy sector in my understanding. Recently, energy sector needs to satisfy an increasing demand. More decentralized power system like renewable energy are being integrated into the system. Load flows are very complex. Consumers and the producers' roles are changing. And more consumers are generating their own power. And as more renewable energy are connected into the system, intermittency and grid stability will be more and more challenging to control. And digitalization of the energy sector will support the energy transition by supporting the energy by supporting the integration of decentralized energy source and renewable energy in a way that the grid can run reliably, securely, and efficiently. And there are several decentralization technologies, digitalization technologies of the energy sector. One is a microgrid or smart grid, and remote infrastructure maintenance, and real-time management softwares, and big data and artificial intelligence, and blockchain. All these kind of technologies are now being used in the energy sector also. And these technologies will be explained in the next paper and after. The smart grid introduced the two-way dialogue where electricity and information can be exchanged between utility and its customers. In short, the digital technology that allows two-way communication between the utility and its customers, and the sensing along the transmission line is what makes the grid smart. Like the internet, the smart grid will consist of controls, computers, automation, and new technologies and equipment are working together. But in this case, these technologies will work with electrical grid to respond digitally to our quickly changed electric demand. There are several benefits associated with the smart grid. One of them is more efficient transmission of electricity. Another is quick restoration of electricity after power disturbances. The other will benefit from the smart grid. And next technology is the remote infrastructure maintenance. In the electrical energy sector, electrical equipment such as transmission line and transmission towers are key components. Solar panels is also a key component in the renewable energy sector. So the maintenance of the electrical equipment is much important to keep these equipment running well. Digitalization technologies of synthetic aperture radar satellite or a drone is being used for monitor the electrical equipment remotely. Maintenance staff need not to go the field of the electrical equipment to check its status. This technology can shorten the maintenance time and make the maintenance safer. And the next technology is the real-time management softwares. Once generated, electricity has to be consumed. Many renewable energy, like solar power, are intermittent power sources. The solar power system produces their power during the daytime. If not consumed, this electricity surplus is lost. To avoid this problem, one option is the introduction of high voltage cables called interconnectors that enables surplus power to be traded and shared between countries. Another option is to use a low-cost, large-scale energy storage for the grid. Both systems can be successfully implemented, but in order to control this surplus generation, cutting-edge softwares to track the energy flow are required. For the battery systems, it is necessary to control the charge and the discharge by the cutting-edge softwares. And big data and artificial intelligence are also topics every day, everywhere. This situation is the same in the energy sector. The electricity generation changes in real time and monitored in seconds. The electricity consumption is monitored as well. The data is exactly big data. For example, by analyzing the big data of your electricity consumption, your lifestyle might be revealed. So the data must be handled with the most consideration of privacy and security. The artificial intelligence in the energy sector. The artificial intelligence has already been used to forecast the tomorrow's electricity demand or renewable energy generation. So the artificial intelligence is also being used in energy sector. Next technology is the blockchain. I think you may know the blockchain. The blockchain began to be used in the energy sector also. As you know, blockchain is a growing list of records called blocks that are linked together using cryptography. In conventional electricity trading, we, consumer, buy electricity from the utility company and use the electricity. Seller is the utility. Buyer is consumers. What will change when the blockchain is used for the electricity trading? This figure shows an electricity trading example where the blockchain is used. Every transaction, every sell order, and every buy order is registered into the blockchain. No one can manipulate the transaction after it is registered. A contract is concluded between a seller and a buyer in the blockchain. Every participant in the blockchain can be both seller and buyer. No centralized organization is necessary. No utility company exists in this example. The blockchain can also certificate the source of electricity. A person or a company who commits a decarbonization can buy the electricity of which source is the renewable energy. I briefly explained several digitalization technologies. From now, several examples of the digitalization technologies implemented in Japan. This figure shows the outline of the demonstration project by the Ministry of Environment, Japan. The Ministry of Environment, Japan has started demonstrating a real-time consumer-to-consumer trading platform for CO2 reduction value of renewable energy for social implementation and commercial use of the result of renewable energy CO2 reduction value creation model business utilizing blockchain technologies. The Ministry of Environment has created an environmental value related to the reduction of CO2 emissions from self-consumed renewable energy that has not been fully evaluated or utilized, and blocked a platform that can freely trade that value together with attribute information at low cost. This implementation period is scheduled for 5 years since 2018. Another example is a microgrid in Miyako Island in Okinawa Prefecture in Japan. For this project, please see the movie.
An emerald green ocean, colorful nature, and a bright sun. These are what define the island of Miyakojima. Here you will find many initiatives designed to protect the island's rich nature and environment. A promise made in the declaration of Eco-Island Miyakojima. Solar panels, large capacity storage cells, and an energy management system.
And the energy management system in Oki Island. In this project, solar power generation and wind power generation and battery storage system were installed in addition to the existing diesel generators, hydro generation and wind power generation. Lithium-ion and sodium sulfur battery were used. By this project, renewable energy penetration capacity could be enhanced from 3 megawatt to 11 megawatt. I introduced several Japanese cases. Then I want to explain my understanding of the renewable energy situation in Indonesia. This graph shows the final energy consumption in Indonesia. Indonesian economy is growing. Along with the economy growth, the final energy consumption is growing as well. The final energy consumption of the year 2030 is expected to be twice the energy consumption as of the year 2014. And this graph shows the fuel mix in primary energy supply in Indonesia. In 2016, the renewable energy penetration ratio is only 3%. The ratio is expected to over 25% in 2050. So the Indonesia is aiming to expand the renewable energy penetration. This is another example. RUPTL, prepared by PLN, mentioned the solar power generation. Pembakit Listrik Tenaga Surya, PLSTS. In this RUPTL, provision mentioned program PLTS 1000 Pulau Lokasi. In this program, PLN is planning to introduce solar power generation into 1,000 islands or locations. This provision shows also the Indonesian aim to expand the renewable energy penetration. To the Indonesian situation on the renewable energy, I want to propose OCG's contribution to Indonesia. We have several experiences of feasibility study and the design of several microgrid systems. There are a lot of islands in Indonesia, so OCG can propose the microgrid system into the island, especially into the islands where the electrification ratio is comparably low. The microgrid may include renewable energy, a battery energy storage system, electric mobility, and so on. By introducing a microgrid to the islands, power supply reliability is expected to be improved, and mobility inside islands will be improved as well. In future, not only the renewable energy and the electricity mobility, but also disaster prevention, sightseeing industry, and so on, it can be smarter, and the island can become smart islands. OCG is hoping to have a chance of this kind of renewable and smart project to contribute to Indonesia's decarbonization and sustainable development. Terima kasih atas perhatian Anda. Thank you for your kind attention.
Yeah, thank you very much, Yamada-san, for the presentations. It is 20 to 25 minutes duration. It's good for us. Okay, just to summarize what Yamada mentioned in the presentation, he was talking about digitalization in the renewable energy, and he mentioned about digitalization, which consists of IoT, big data, artificial intelligence. I think this is something that participants can ask later on in the question and answer session. And OCG also proposed a kind of value proposition for renewable energy development in Indonesia. As we know that we have RUPTL, which is basically a PLN power generation and transmission planning, which need to be renewed every year for 10 years term. Okay. For the second speaker, we have Pak Dani Pomanto, our city mayor now. Pak Dani, silahkan Pak. Terakhir ketemu Pak Dani 3 tahun yang lalu Pak, sebelum COVID nih. Kita pernah diskusi mengenai smart city development di Kota Makassar. Silahkan Pak Dani Pomanto.
Hello?
Yeah.
Hello, are you hearing me?
Yeah, we can hear your voice.
Yeah, on behalf of Pak Dani Pomanto is coming now. Mungkin take time dulu. Hello, Pak Dani Pomanto just came. I think he needs maybe 5 to 10 minutes to take time because he just arrived. Could you please allow him to take some time before he begins?
So you can get the question and answer.
Okay.
I think you can start with the question and answer first from Mr. Yamada.
Okay. Yeah, thank you, Ibu. Yeah. Okay, Yamada-san, I think let's just move to the question and answer session, yeah, for the first speaker.
Mana materi tak? Railway transportation Pak, atas bahasa Indonesia saja.
Oh gitu.
Iya, nanti dia translate.
Apa anunya?
Symposium, International Symposium tema Railway Technology Development.
Kasih bagus gitu lah, no. Zoom.
Oh, maybe Pak Dani sudah siap Pak. Silakan senior.
Oke Pak, siap. Sorry nih saya very tight schedule, jadi mohon maaf ya, I'm late ya. Oke, kita mulai Pak ya.
Silakan Pak, silakan.
Oke. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Yeah, I would like to say thank you for this invitation for me to attend this Zoom seminar about the development of railway transportation in Makassar City. I will introduce my presentation with bahasa. Okay. Okay, this is about the Makassar city. Now is the total populations 2021 Makassar. Yeah. Next. Yeah. Next. Okay. Ya itu dulu ya. I will update the total the data of about the total population to 1.4, but now is 1.5. 1.5 now, 2021. This is about the district, 15 district, sub-district, and citizen association is RW, RW 996 dan RT 4978. Next. This is about the silent model of citizen movement in Makassar, model pergerakan bangkitan.
Pak Dhani, mungkin ininya speakernya di unmute.
Oke. Bisa ya? Tadi unmute ya? Oh. About if we discussion about the transportation, we have two big topic. The first is about the spatial plan. The second is about the Tatra Log. About the spatial plan, Makassar has a special plan, the newest spatial plan, 2015 to 2064. This is the map, about the pola ruang and struktur ruang, Sum, bertanya Sum bertanya ya. Bertanya ya. Kasih lihat petanya. Kasih lihat petanya.
Belum kelihatan share screen-nya, Pak.
Oh, astaga. Share screen-nya belum. Iya. Aduh, belum masuk. Kenapa bisa gitu? Aduh. Sangat tak profesional kita. Kenapa? Mohon maaf ini Pak, mohon maaf ini. Saya pikir tadi.
Nah, sudah kelihatan Pak. Bisa
tadi dari tadi belum kelihatan Pak ya?
Tadi di awal kelihatan.
Oh gitu. Oke. This is about the spatial plan of Makassar. Sum gambarnya. Gambar mapnya, Sum. Gambar mapnya, Sum. Tadi, sebelah situ. Aduh. Ini mohon maaf ini Pak. Ini bisa ya? Oke. Ini adalah pola ruang Kota Makassar yang terdiri atas pola ruang yang pertama adalah A, itu pusat kota. Ini terlihat betul-betul downtown kita. Kasih zoom, kasih kecil supaya utuh. Ya. Nah, terlihat bahwa A itu adalah downtown kita. Kemudian kalau saya lihat mulai dari pesisir, yang I itu adalah namanya kawasan global terpadu, yaitu sebuah kawasan terdiri sebagian besar adalah kawasan reklamasi, diharapkan menjadi pusat bisnis baru yang berwawasan global. Nah, ini menjadi bangkitan baru dalam transportasi Kota Makassar yang menjadi bahagian yang harus kita perhitungkan di masa yang akan datang, termasuk bangkitan kaitannya dengan railway ataupun dengan LRT. Tentunya railway kita berakhir, kalau kebijakannya kemarin berakhir di endingnya ada di Makassar Newport yang kemudian akan dihubungkan dengan feeder. Nah, bangkitan-bangkitan inilah yang punya potensi untuk menjadi bahagian daripada bangkitan-bangkitan dari LRT, merupakan feeder daripada railway. Itu yang I. Nah, begitupun yang H. Yang H itu adalah disitulah kawasan kawasan pelabuhan terpadu, di mana tentunya intinya adalah Makassar Newport bersama dengan ada 1000 hektar kawasan industri penyokong Newport, termasuk misalnya bonded warehouse, kemudian bonded zone secara keseluruhan. Di H ini bangkitan-bangkitan yang sementara hari ini menjadi sudah selesai beberapa tahap untuk Newportnya, dan kalau dilanjutkan dengan backup kawasan di mana kawasan 1000 hektar di samping Newport itu menjadi bahagian yang menjadi bangkitan dari sistem transportasi kita, terutama untuk railway. Nah, begitupun dengan G. G itu adalah kawasan maritim terpadu. Adalah sebuah kawasan termasuk pemukiman, kemudian beberapa industri, termasuk kawasan fishport kita dan beberapa kawasan pendidikan. Nah, kawasan-kawasan ini tahun ini dan tahun depan kita akan mengadakan revisi. Nah, sehingga khusus kawasan-kawasan baru baik I, kemudian H, G, dan J. Nah, J ini kawasan olahraga terpadu. Kawasan ini untuk memfokuskan kegiatan-kegiatan olahraga yang kemudian ini peta lama. Ini mohon maaf, ini peta rupanya peta lama ini. Nah, ini saya mohon maaf, ini baru lihat presentasinya juga ini. Saya baru diberikan presentasinya, mohon maaf ya. Tapi paling tidak filosofi ruangnya seperti itu. Terus next. Tata ruang lama. Next. Yang tadi, yang di bawahnya tadi, yang tata ruang ya. Local transportation arrange of the code Tatralog Makassar in 2019 describes the future of Makassar city transportation system that is integrated with the development of transportation facilities and infrastructure, which are summarized in Makassar City Traffic Network and refer to Makassar City Regional Development Policies. Nah, kita bisa lihat di situ bagaimana struktur ruang kemudian dikonektivitaskan dengan jalan-jalan, ya baik itu jalan kereta api, LRT, jalan tol, jalan inner ring road, dan jalan-jalan penghubung lainnya, terutama arteri, ya termasuk juga jalan dengan water transportation, termasuk antara bagaimana menghubungkan Sungai Jeneberang ke Sungai Talo, termasuk ke Sungai Balangberu di perbatasan dengan Maros. Dan ini semua akan kami revisi tahun ini, dan maka dengan itu kami mohon masukan-masukan dalam seminar ini. Terus next. Tentang intercity public railroad, saya kira saya tidak usah bahas di sini. Paling tidak dari informasi yang kami peroleh bahwa railway kita sampai di ujungnya ada di posisi Makassar Newport, yang kemudian kita akan hubungkan dengan feeder dalam bentuk LRT, Light Rapid Transport. Yang kemudian bagi pemerintah Kota Makassar menginginkan railway kita maupun LRT kita semua adalah elevated. Kenapa elevated? Karena kita tidak mau kalau landed terlalu banyak risiko-risiko ketata ruangan dan risiko-risiko yang cukup besar yang ditanggung oleh Kota Makassar, terutama di dalam separate wilayah antar wilayah yang sebelah dan dipisahkan oleh landed railway ini. Makanya kami mengambil kebijakan semua elevated railway. Terus, nah ini adalah railway network system plan ya Tata Ruang 2019. Tapi kita juga memiliki beberapa feeder-feeder karena di Makassar itu positioning Makassar dan karakteristik Makassar itu kalau kita utara selatan continuous route kita cukup banyak ya. Akan tetapi antara barat dan timur kita tidak memiliki continuous route yang memadai. Semua terputus. Padahal perpindahan antara barat dan timur baik bangkitan dan tarikan transportasi kita itu pergerakan barat dan timur. Dulu waktu kami masih sebelum jadi wali kota di tahap pertama kami mengukur ada 675 flat ya yang bergerak ya penumpang yang bergerak tiap hari 675.000 orang bergerak ke barat ke timur dan timur ke barat. Itu pada saat 10 tahun yang lalu. Saya perkirakan mendekati 1 juta pergerakan orang timur dan barat dan tidak didukung oleh continuous road atau continuous street yang bisa memperlancar sistem transportasi baik individu maupun public transport. Nah sehingga inilah menjadi masalah paling besar yang dialami Kota Makassar, sehingga LRT adalah bahagian daripada salah satu solusi untuk menghubungkan antara bangkitan dan tarikan transportasi timur dan barat. Karena utara selatan kami memiliki 4 koridor ya street koridor yang cukup bagus antara daerah paling selatan menuju daerah paling utara Kota Makassar. Terus saya kira ini teknis saja untuk stasiunnya. Terus nah saya kira kalau ini sudah pasti banyak yang lebih ahli di sini, tapi saya ingin menerangkan filosofi Kota Makassar yang ada pada map yang kedua. Kita bisa lihat bahwa Makassar memiliki double loop. Jadi ada double loop dan ketemunya itu intinya itu ada di Makassar Newport. Apa artinya ini? Ini kembali menjadi bahagian daripada anatomi Makassar yang selalu hidup dari pelabuhan. Kita tahu bahwa sejarah Makassar itu berawal dari Sungai Talok, yang kemudian di sekitar Pautere, yang kemudian setelah dangkal dia pindah ke Sungai Jeneberang. Setelah Sungai Jeneberang terjadi perang Goa Makassar waktu itu dengan VOC, kemudian pindah di depan Benteng Jumpandang. Nah, jadi semua perkembangan kota ini tergantung oleh pelabuhan. Dan alhamdulillah ternyata secara anatomi kita bisa lihat bahwa dari loop di selatan dan loop di northern loop dan southern loop ini intinya semua simpulnya ada di pelabuhan. Sehingga kembali lagi Makassar dengan anatominya bahwa pelabuhan menjadi bahagian daripada hal yang paling penting atau jantung Makassar, karena Makassar hari ini punya 4 ekonomi core. Jadi core ekonominya ada 4. Pertama trading, yang kemudian bisnis, kemudian hotel dan restoran atau tourism, dan yang ketiga adalah properti. Nah, maka Makassar sangat kokoh ya karena kita punya 4 core ekonomi yang menopang Makassar, dan tentunya connectivity yang baik dengan rencana elevated toll road inner ring road kita bersama-sama dengan toll road di utara berkoneksi langsung dengan Makassar Newport dalam bentuk loop selatan dan loop utara, saya kira ini akan menambah kemampuan Makassar baik dari GDP growth-nya maupun dalam inflation rate-nya. Karena dua hal itu memberikan ukuran-ukuran tentang kesehatan ekonomi atau peluang-peluang ekonomi sebuah kota, yaitu antara ekonomi growth kita yang dulu waktu legasi saya awal terakhir 8,79%, kemudian dengan inflation rate sekitar 3,5%, dan sekarang setelah during pandemi kita sudah rebound, ya sudah di atas 4%. Bahkan saya lagi menunggu laporan terakhir, tapi yang kami dapat terakhir bulan April itu kita sudah pada posisi 4, padahal bulan Februari itu kita masih minus 1,27%. Nah, saya kira hadirnya kereta api akan memberikan sebuah trigger atau menjadi kick off Makassar untuk terus rebound, ya, dan menjadi bagian dari bangkitan ekonomi Indonesia dalam rangka economic recovery atau pemulihan ekonomi nasional. Terima kasih, lebih dan kurang dimaafkan, mohon maaf ada kesalahan teknis. Makassar ini smart city, tapi tadi saya lihat kurang smart tadi presentasinya, tidak apa-apa ya, karena saya juga tiba-tiba mohon maaf, saya kebetulan begitu banyak agenda sehingga persiapannya tidak terlalu firm, tapi insya Allah dalam diskusi nantinya saya kira bisa banyak hal yang bisa kita akan sampaikan. Terima kasih. Assalamualaikum warahmatullahi wabarakatuh.
Ya, terima kasih banyak. Ya, paparannya Pak Dhani menarik sekali. Kita tadi melihat akan ada rencana tata ruang baru gitu, dan teman-teman Pemkot membutuhkan masukan gitu, inputan dari teman-teman semua gitu. Kemudian yang kedua tadi terkait rencana LRT di west to east ya, karena di north to south sebenarnya sudah didukung oleh beberapa ruas jalan ya, mungkin ruas jalan tol dan non tol tadi. Pak Dhani, bolehkah kami meminta 1-2 pertanyaan saja dari teman-teman sebelum meninggalkan forum? Apabila memang waktunya nggak bisa, Bapak nggak bisa sampai sore. Pak Dhani, boleh kami membuka babakan pertanyaan Pak, khusus untuk sesi Bapak?
Buka saja.
Ya. Ayo teman-teman yang mau bertanya, saya persilakan 2 penanya saja untuk sesi Pak Dhani ya. Nanti pembicara yang lain kita akan lanjutkan di sesi question and answer setelah semua speaker menyelesaikan paparannya. Silakan Pak, apabila ada pertanyaan.
Pak Habibie, mohon izin bisa bertanya sedikit kepada Bapak Wali Kota. Saya Yasa Gunadi, Pak.
Pak Yasa, silakan Pak.
Selamat siang, Assalamualaikum Pak Wali Kota. Saya hanya ingin bertanya saja, kalau tadi dari pemaparan Bapak itu kebanyakan rencana perkeretaapian di Makassar itu untuk penumpang ya Pak ya. Apa tidak ada untuk angkutan barang gitu Pak? Karena kalau saya lihat tadi semua rencana elevated tentunya ya. Mungkin di pemikiran saya bukan civil engineer ya Pak ya, jadi pemikiran saya itu kalau semua elevated tentu kalau untuk angkutan barang kan harus perencanaannya juga harus bagus itu ya, jembatan harus kuat dan sebagainya. Apa ada rencana untuk angkutan barang juga Pak? Terima kasih Pak.
Ya, Pak Wali Kotanya kayaknya udah terlanjur keluar nih Pak Yasa. Tapi nggak apa-apa,
ya,
pertanyaannya kita jawab.
Lanjut aja Pak, kita yang lain. Terima kasih.
Kita simpan aja dulu. Siapa tahu nanti Pak Wali Kotanya masuk lagi gitu kan. Oke. Saya rasa kita lanjut ke speaker ketiga ya. Pak Yomil ya, Pak Yomil is the speaker representing PT Wijaya Karya Beton. He's based in Jakarta. He's currently assigned as a marketing manager for overseas projects. Pak Yomil, time is yours. Thank you.
Oke, thank you Pak Habibie. Oke, Pak, mungkin sebelum mulai presentasi saya mau nanya dulu. Ini kita mau presentasi bahasa Inggris, bahasa Indonesia.
Di mix aja Pak Yomil.
Ya,
Oke, siap,
di mix
Bapak.
aja Pak, silakan.
Ya, oke, saya izin untuk presentasi ya Pak ya. Mas Randi, saya minta tolong di share ininya presentasi saya.
Baik Pak.
Alright, okay, thank you, Pak Habibie. Thank you for the time. And today, I will present about the construction of ballastless track in our project in Jakarta, light rail transit project. Next, please. Okay, let me introduce myself. My name is Yomil Rafianda. My expertise is in the civil engineering, project management, and railway systems engineering and integration as well. So I got my first degree in Andalas University in Padang, and after finish my project, the LRT Jakarta project, I continue my master degree in the University of Birmingham in the United Kingdom, and I got the master in railway systems engineering and integration. And I also got my professional engineer from the Universitas Gajah Mada. I start my career in the Wika Group, in the Wika Beton as the assistant site managers in 2010, and after that I got a lot of elevated projects in Jakarta, and in 2011 I got the marine project in the Australia, because we got a contract from Saipem, the oil and gas construction from France. And in 2017, I'm in charge as the deputy project manager for the track work, for the APC track work in Jakarta LRT project from Velodrome to Kelapa Gading. Because our holding company Wika got the contract from JPRO as the client. And right now I'm in charge of the overseas marketing manager of Wika Beton, and so it means I'm responsible for project in the overseas. Okay, next please. Oke, ini milestone dari Wika Beton. Jadi kita starting sebagai salah satu divisi di Wika itu di tahun 1978, di mana kita waktu itu dapat penugasan untuk mengganti sleepers kayu dari Kementerian Perhubungan menjadi sleeper beton. Jadi disinilah sebenarnya awal mulanya Wika Beton. Dan setelah itu kita continue untuk produksi produk-produk yang lain. Di tahun 1997, Wika Beton tidak lagi menjadi divisi di Wika, tapi adalah menjadi anak perusahaan. Dan untuk produk-produk terus berkembang, kita mulai masuk ke jembatan PCU girder, karena waktu itu DKI berharap tidak ada e-girder lagi, dan girder untuk menggantikan jembatan-jembatan di DKI supaya secara estetika lebih baik. Terus di tahun 2014 Wika Beton melantai di bursa, kita melakukan IPO. Jadi kalau sekarang bapak-bapak yang suka main saham sudah bisa bisa lihat pergerakannya Wika Beton di pasar modal. Terus di tahun 2017 Wika Beton dapat kontrak ETC Track Work, Engineering Procurement Construction and Commissioning di Jakarta LRT Project di bawah Jakarta Propertindo, anak usahanya Pemda DKI. Terus untuk 2020 kita memiliki strategic business unit baru untuk structural health monitoring system, karena untuk produk-produk jembatan khususnya precast beton itu mungkin hampir 70-75% dari Wika Beton, sehingga berdasarkan requirement sekarang dari pemerintah yang harus mensyaratkan untuk melakukan structural health monitoring system, akhirnya kita buka strategic business unit yang baru di Wika Beton. Dan ini kalau kita lihat aplikasinya hampir mirip dengan bagaimana persinyalan di kereta api melakukan monitoring. Jadi kita juga punya OCC-nya sendiri di Jakarta untuk memonitor kesehatan dari jembatan-jembatan yang ada di Indonesia. Oke, next please. Oke, tadi Pak Wali Kota sudah banyak memaparkan tentang kebutuhan mengenai urban railway di Kota Makassar, di mana perpindahan orang dari satu titik ke satu titik yang lain diperkirakan sudah melebihi 1 juta orang per harinya. Nah, artinya berarti kebutuhan akan baik itu light rail transit atau mass rapid transit and everything, mungkin ini juga di Kota Makassar perlu kita dalami lagi sehingga bisa memenuhi kebutuhan pergerakan orang di Kota Makassar. Jadi kalau kita perhatikan di sini, ini sekilas mengenai proyek yang kami lakukan dari velodrome ke Kelapa Gading di Jakarta Utara ya. Jadi proyek ini kita siapkan untuk bisa membantu pergerakan atlet waktu itu, karena proyek ini harus diselesaikan untuk Asian Games yang ke-18 tahun 2018. Kalau secara panjang untuk di mainline memang tidak terlalu panjang, 6 kilo, tapi di sini hal yang cukup fantastis adalah deponya, karena saat itu pembangunan depo langsung diperuntukkan untuk 60 trainset, dan di sini ada keunikan tersendiri karena depo yang kita bangun tracknya untuk fasilitas segala macam ini bukan di grade ya, tapi berada pada lantai 2. Jadi kesulitan-kesulitan yang kita hadapi saat pembangunan track di depo cukup lumayan, dan secara total panjangnya hampir 20 kilo ya untuk track yang ada di depo, karena juga ada peruntukan untuk test track dan segala macam di sana. Next please. Oke, ini adalah contoh sistem slab track yang kita bangun di LRT Jakarta. Mungkin sekilas ini hampir mirip dengan apa yang dibangun pada MRT Jakarta, tapi ada keunikan tersendiri di sini. Yang pertama, di LRT Jakarta yang under Japro, kita untuk powernya menggunakan third rail atau rel ketiga. Sedangkan kalau di MRT Jakarta kita powernya berada pada OCS, overhead catenary system. Dan yang lebih unik lagi, sistem yang kita pasang di sini, karena bapak-bapak semua di sini, bapak atau ibu bisa lihat di sini tidak ada penggunaan batu balas atau balas ya, batu pecah yang berfungsi sebagai dumper. Jadi karena kita di sini menggunakan embedded sleeper yang kemudian kita showcase in situ di lapangan. Artinya tidak ada balas yang berfungsi sebagai damper. Tetapi untuk penggantian balas tersebut kita menggunakan sebuah sistem di mana anti-vibration-nya kita pasang di pada fastening sistemnya. Jadi anti-vibration-nya langsung berada di posisi di bawah relnya, sehingga untuk proses kecepatan dan segala macam akan lebih baik. Dan kalau kita bandingkan dengan MRT Jakarta, anti-vibration ini secara secara overall cost include dengan maintenance ini akan lebih murah. Jadi secara keseluruhan sistem ini akan lebih reliable. Next please. Foto yang kami ambil di LRT Jakarta Project, di mana penggunaan sleeper kalau secara track gauge ini sama dengan yang digunakan pada pembangunan railway di Makassar, di mana track gauge-nya 1435. Dan ini waktu pertama kali diputuskan mungkin menjadi perdebatan yang cukup banyak di Jakarta, karena kita tahu selama ini track yang peninggalan Belanda itu adalah 1067. Jadi baik itu yang untuk mainline ataupun yang dipasang di MRT Jakarta. Tapi ketika pembangunan LRT Jakarta kita menggunakan track gauge 1435. Oke, next please. Nah, ini tadi yang saya bicarakan. Kalau Bapak-Bapak lihat di sini, bagian yang melingkar ini adalah test track-nya. Jadi kita bangunnya tidak at-grade, dan kalau kita lihat stabling itu ada di bangunan-bangunan gedung untuk bisa menampung 60 transit kereta. Nah, kalau kita lihat di sana ada satu bangunan lagi yang seperti belum jadi, yang di sini. Ini nanti akan dijadikan area apartemen oleh Pemprov DKI. Jadi kalau kita lihat keinginan Pemprov DKI saat itu adalah mengintegrasikan stasiun yang ada di depo ini dengan apartemen ataupun area perbelanjaan, sehingga mobilitas orang bisa lebih mudah dan reliable life itu bisa tercipta di sini, karena sistemnya depo ini langsung bisa dijadikan TOD, sehingga keinginan orang untuk tinggal di transit oriented development ini juga lebih besar, karena adanya kemudahan akses yang terhubung dengan LRT Jakarta. Next please. Oke, mungkin sedikit lebih teknis, kita pindah ke main scheme of construction method. Jadi keunikan lain dari LRT Jakarta yang kita bangun saat itu tahun 2018 adalah penggunaan rail welding, di mana rail welding yang kita gunakan saat itu adalah sistemnya place butt welding. Jadi mungkin kalau bapak-bapak yang biasa main di track, kita tidak menggunakan poison lagi yang terjadi pembakaran untuk penyambungan relnya, tapi di sini kita bisa lihat menggunakan elektrik. Jadi secara hasil akhir itu lebih baik untuk kenyamanan berkendara kalau kita coba di keretanya. Terus untuk sistem yang kita lanjut tahapan kedua, itu ada namanya track setting dan civil work. Jadi di mana sleepers dan rail ini diinstall dan rebar dan segala macam untuk secondary pouring kita lakukan. Terus yang ketiga concreting, karena kita di sini tidak menggunakan batu balas, jadi tracknya kita lakukan pengecoran Terus ada beberapa hal yang tidak boleh ketinggalan untuk sistem balastless ini, yaitu adalah kegiatan stressing dan distressing dari rel itu sendiri. Jadi kita membiarkan rel itu memuai. Kita biasanya melakukan aktivitasnya dari jam 7 pagi sampai jam 10 pagi. Jadi relnya kita biarkan memuai. Setelah mencapai maksimum muainya, rel tersebut kita potong dan langsung kita join lagi per 250 meter. Terus di sini juga ada kegiatan third rail installation tadi yang seperti yang saya bilang, sistem powernya menggunakan third rail, tidak menggunakan overhead catenary seperti yang di komuter lainnya Jakarta ataupun MRT Jakarta. Oke, next please. Oke, ini sekilas lebih detail tentang welding. Jadi rel yang 25 meter kita lakukan penyambungan menjadi 250 meter dan teman-teman di lapangan melaksanakan aktivitas pengerjaannya dengan penggunaan rel sepanjang 250 meter. Jadi secara sequence of construction ini agak lebih bisa mempercepat kegiatan karena kegiatan instalasi trek dilakukan atas 250 meter rel, long rel track. Next please. Ini sekilas mengenai track setting. Mungkin tidak ada hal yang terlalu aneh untuk kegiatan track setting. Tapi yang sebagaimana yang kita ketahui untuk di LRT Jakarta secara toleransi hitungannya mili, jadi benar-benar menuntut keakurasian yang sangat tinggi. Jadi toleransinya hanya 2 sampai 2,5 mili. Oke, next please. Oke, ini untuk civil work-nya. Tadi yang saya sampaikan, karena di sini kita melakukan secondary pouring, jadi ada penginstalan rebar dan pengecoran terhadap slab track-nya sendiri. Kalau untuk foto jadi bisa kita lihat di sisi kanan ini, Bapak-bapak. Oke, next please. Nah, ini untuk gambaran third rail installation. Ini produk kita berasal dari Jerman. Untuk pemasangan si third rail ini juga diperlukan akurasi yang tinggi karena nanti shoe dari kereta itu harus menempel di third rail ini. Dan supaya tidak terlalu jadi gesekan yang sangat kuat, jadi pas saat pemasangan ini benar-benar harus akurat supaya tidak mengakibatkan kerusakan pada kereta nanti. Oke, next please. Oke, ini contoh special tracks yang kita jot. Ini yang untuk gambar sebelah paling kiri ini berada pada posisi mainline track sebelum masuk ke depo. Di sini kita menggunakan clean track, di mana tidak menggunakan slipper dan semuanya adalah full secondary pouring. Terus untuk gambar yang di tengah ini kita fokuskan track depo. Di sini biasanya digunakan untuk area perawatan bagian bawah kereta. Dan pada gambar sebelah kanan ini ada namanya embedded track depot. Ini biasanya untuk berada pada posisi area perawatan juga di depot sendiri. Next please. Oke, ini contoh buffer stop installation yang kita lakukan di depot. Jadi biasanya untuk untuk antisipasi supaya kereta tidak lewat dari jalurnya, kita harus pasang buffer stop di ujung jalur yang ada di depot station. Terus Kalau kita lihat sekilas seperti ini ya Bapak Ibu ya, yang untuk gambar sebelah kiri. Terus di sini juga ada wheel stop. Ini gunanya kalau di mobil ya kayak kayu ganjil. Oke, next please. Oke, tadi sekilas ini LRT Jakarta yang kita bangun. Selanjutnya saya mau sampaikan beberapa proyek yang dimana Wika Beton juga involved di sini, yaitu untuk pembangunan MRT Jakarta fase 1. Di sini kelihatan ada beberapa produk yang berasal dari Wika Beton. Yang pertama itu adalah catenary pole yang untuk OCS. Terus yang kedua untuk elevated box feedernya dari Wika Beton juga, dan untuk parapet wall itu juga precast. Dan sebagai informasi, pada saat pembangunan MRT Jakarta ini terjadi sedikit kemunduran schedule, dan untuk mempercepat construction, saat itu dari beberapa konsorsium Jepang memutuskan untuk konstruksi station yang semula adalah cast in situ diganti menjadi precast untuk mempercepat penyelesaian proyek. Jadi saat itu ada beberapa station di sepanjang main line yang akhirnya desainnya kita rubah menggunakan precast, dan precastnya sendiri diproduksi di Wika Beton. Slipper yang baik itu di main line dan underground di MRT Jakarta juga berasal dari Wika Beton. Jadi sebagai informasi, untuk pekerjaan sipil di MRT Jakarta itu ada 4 station, ada beberapa section, itu mulai dari CP 101 until CP 106, dan untuk pekerjaan track dan sistem itu ada di CP 107, dan untuk CP 101 until CP 106 almost 80% of the precast concrete coming from Wika Beton. And for the activity in the CP 107, for the track walk and system, the sleepers, the design of the sleepers is coming from Wika Beton. And for the next package of the MRT Jakarta, for the track walk activity, Wika Beton will involve in the consortium as the contractor for the track installation. Okay, next please. This is the precast tunnel for the underground of MRT Jakarta. For information, 100% of the precast tunnel that used in the MRT Jakarta Phase 1 were coming from the Wika Beton, and right now for the second phase also coming from Wika Beton. This is like a honor for Wika Beton can contribute for the construction of the MRT Jakarta Phase 1 and Phase 2 as well. Next please. Okay, thank you for your kind attention, and thank you Pak Habibie for the time.
Yeah, thank you Pak Yomil. It's such nice presentation. Yeah, giving more insights, knowledge on the technology of civil engineering, more on civil engineering in railway projects. I think so. As we know that Wika was involved in LRT Jakarta Phase 1, I think from Kelapa Gading to Velodrome. The second project was presented is the involvement of Wijaya Karya Beton also in MRT project, MRT Jakarta, where Wika is 100% supply the precast tunnel for this project. So that's very insightful information for us to understand more later on the technology of the precast. as we may know that Pak Yomil soon is going to leave us. He's going to the airport. He has a plan to catch up. Maybe we can open the question and answer session for Pak Yomil. If we have questions, participants here would like to raise questions, please go ahead. I have some question also in the room chat. If you don't mind, I'm going to read it for you. The questions coming from Pak Yasa. Pertanyaan kepada Pak Yomil, pada sistem ballastless track ini tadi disebutkan bahwa untuk vibration isolationnya dilakukan oleh rail faster atau clipnya. Pertanyaannya, yang meredam apakah spring clipnya atau ada juga rubber mat di clipnya? Kalau ada karetnya kan pasti umurnya juga setelah waktu tertentu akan performancenya akan turun. Karena karet akan jadi keras setelah beberapa waktu. Setiap berapa lama karet tersebut harus diganti kalau memang ada karetnya? Kira-kira itu pertanyaannya. Kemudian pertanyaan kedua, kemudian apakah ada expansion joint di railnya? Kira-kira itu Pak pertanyaan teknis dari Pak Yasa. Silakan Pak Yomil Pak, jawab Pak. Masih mute Pak? Bisa di-unmute ya?
Iya, masalah vibration system yang kita gunakan di LRT Jakarta, benar untuk anti vibrationnya ada lapisan karet yang kita taruh di underneath rail. Jadi ada beberapa lapis, 3 lapis, tapi lapisan ini sangat tipis. Jadi kalau kita lihat secara sistem tidak terlalu mempengaruhi ya, karena secara visual ini tipis, tapi secara penggunaannya ini sangat mampu ya untuk meredam kalau kita bandingkan dengan rubber boot yang dipasang di MRT Jakarta. Kalau rubber boot yang dipasang di MRT Jakarta itu posisinya underneath sleeper. Jadi ada rubber yang membungkus bagian bawah dari si sleeper di sisi kiri dan sisi kanan. Dan ini secara visual kelihatan banget. Terus kalau kita bandingkan secara maintenance, artinya juga ini akan menjadi kesulitan ya kalau di MRT Jakarta, karena kita harus melakukan bobok lagi untuk slab tracknya sendiri. Tapi kalau yang dipasang di LRT Jakarta, misalkan si anti vibrations nya terjadi kausan, kita tinggal lepaskan fastening, rel kita angkat, mat rubbernya kita tarik, kita ganti dengan rubber yang baru. Jadi sangat mudah, baik dari sisi installations ataupun dari sisi maintenance. Mungkin itu Pak Habib.
Ya, oke. Saya rasa itu jawaban dari Pak Yomil ya, Pak Yasah. Apabila ada pertanyaan selanjutnya mungkin kita bisa offline ya. Mungkin bisa diatur sesi ngopi-ngopi lah dengan Pak Yomil di Jakarta. Pak Yomil kan base Jakarta, Pak Yasa juga base-nya Jakarta, jadi nanti kita bisa atur lah bikin grup khusus gitu untuk diskusi terkait ini ya. Oke. Ada pertanyaan lagi, mungkin pertanyaan kedua dari Pak Beni. Apabila pertanyaan, langsung aja Pak. Pak Beni Herianto. Ya, Pak Beninya kayaknya lagi enggak ini ya. Oke, saya rasa itu cukup untuk sesi paparan ya terkait teknologi precast untuk proyek railway yang dikerjakan oleh PT Wijaya Karya Beton. Kita lanjut ke sesi selanjutnya, yakni sesi keempat. Kami mengundang Pak Jumadi ya sebagai Kepala Balai Perkeretaapian Sulawesi Selatan untuk memaparkan presentasenya terkait pengembangan railway project ya, railway development di Sulawesi Selatan. Silakan Pak Jumadi. Pak Jumardi mungkin masih mute.
Halo? Nah, oke. Dari tadi saya mau aktifkan tapi dari operatornya nggak bisa. Ya, terima kasih atas kesempatannya. Saya kira banyak sekali pembicara tadi. Tadi pagi bicara khusus MRT dan juga bicara sedikit tentang LRT. Pada siang hari ini saya ingin bicara sedikit bagaimana mewujudkan kereta api perkotaan. Saya izin share paparan saya. Sudah kelihatan, Pak?
Sudah, Pak.
Saya ingin memulai konsep kereta api perkotaan di Indonesia. Jadi di dalam rencana induk perkeretapian nasional itu paling tidak ada 12 yang sudah diidentifikasi kota-kota yang membutuhkan kereta api di dalam perkotaan. Nah, khusus hari ini kita bicara tentang bagaimana kereta api perkotaan itu ada di Makassar. Ya. Saya ingin share pengalaman saya sebagai project manager LRT Jabodebek 3 tahun. Ya. Tadi pagi sudah diekspos sebetulnya oleh Pak Direktur Prasarana, tapi tidak ada salahnya saya ingin berbagi di sini terhadap teman-teman yang ada di Makassar. Kita ketahui bahwa sekarang ini pemerintah sedang membangun jalur kereta api di Sulawesi Selatan, khususnya fokus pada intercity, ya, Makassar, Parepare, di mana panjang lintasannya direncanakan 142 km, kemudian stasiunnya 19, standar gauge, jarak relnya standar gauge, kemudian didesain untuk kecepatan 100 km per jam operasinya, walaupun desainnya 200, kemudian axle load-nya itu 22,5 ton. Ini memang diusulkan untuk mengakomodir angkutan barang. Nah, karena yang kita bicarakan hari ini fokus pada kereta api perkotaan, pertanyaannya bagaimana mengkoneksikan antara kereta api perkotaan dengan kereta api jarak jauh antar kota yang sedang dibangun. Sebetulnya pemerintah, dalam hal ini Kementerian Perhubungan, Direktorat Jenderal Perkeretapian, sudah menyusun master plan kereta api Maminasata pada tahun 2012, dan saya lihat tadi rute-rute ini sudah dimasukkan di dalam rencana tata ruang tatralog, ya, tatralog, tataran transportasi lokal Kota Makassar. Sudah disampaikan oleh Pak Wali Kota. Jadi kalau ini saya gedein. Ini tadi ini sebetulnya sudah diidentifikasi. Jadi tahun 2012 itu kebetulan saya juga project manajernya ini, saya di Direktorat Jenderal Perkeretapian bagian perencanaan. Jadi waktu dibuat ini saya ikut terlibat langsung. Jadi sudah diidentifikasi Maminasata, Maros, Makassar, Sumbu Minasa, dan Takalar itu ada 7 rute, sebagaimana gambar di sebelah sini. Ya, memang ini sudah hampir 10 tahun, mungkin master plan ini perlu juga direview supaya sesuai dengan kondisi saat ini dan tentu ke depan. Nah, di ujung ini ada tanda panah ini, Maros itu dikoneksikan dengan kereta api Trans Sulawesi. Jadi konsepnya sebetulnya awalnya itu kereta api perkotaan itu sampai Maros, kemudian dihubungkan dengan Trans Sulawesi yang sekarang kita kenal dengan Makassar Parepare. Tapi dalam perkembangannya Makassar Parepare sudah melewati Maros, ya, melewati Maros, kemudian sampai saat ini itu dibangun. Di sini ada tertulis Marumpa, ya. Desa Marumpa, Kecamatan Marusu. Di sini akhir daripada pembangunan jalur kereta api yang saat ini sedang dibangun. Kemudian kami melanjutkan tahun depan sedang pengadaan tanah itu dari Marumpa ke arah Tene, kemudian Parangloe, kemudian ke Makassar Newport. Artinya sebetulnya sebagian dari jalur kereta api perkotaan ini sudah disatukan dengan intercity-nya, sehingga kita tidak perlu menunggu sampai kereta api perkotaan itu jadi, yang belum sampai saat ini dimulai itu kita koneksikan dengan bandara. Oleh karena itu kami dalam proses pengadaan tanah ini kami sudah merencanakan dari stasiun Marumpa ini yang sebelah kanan ini ada di bawah ini warna agak kuning, ya, itu ke arah bandara. Kemudian yang di atas juga terus ke Makassar Newport. Jadi sudah kita rencanakan integrasi di sini. Bapak Ibu sekalian, kalau kita lihat memang ya mohon maaf ini sedikit mati lampu lagi di tempat saya. Jadi mungkin sulit untuk saya share. Halo, mungkin dari panitia mungkin
kelihatan sih
bantuan.
Pak. Kelihatan sih ini.
Karena ini mati lampu, dari tadi mati lampu ini. Baru hidup lagi. Jadi saya ingin berangkat dari sini, bagaimana kita mewujudkan? Ya, ini sebentar Pak, ini karena koneksinya langsung terputus tadi. Karena yang satu pakai LAN supaya ini, kemudian yang saya pakai bicara ini pakai HP. Nah, ini permasalahan juga di Kota Makassar, mati lampu juga. Gitu. Jadi tadi sudah dipaparkan tadi di awal-awal bagaimana energi listrik. Sekarang ternyata Makassar mempunyai permasalahan dengan listrik. Ya. Padahal LRT, MRT itu tulang punggungnya listrik. Kalau tidak ada listrik, ya tidak mungkin bisa jalan. Bahkan waktu kita bikin MRT itu sudah kita koordinasikan jauh-jauh awal. Bahkan supaya ini disiapkan listrik karena bergantung pada listrik. Ini masih kelihatan Pak ya?
Udah nggak kelihatan lagi Pak.
Nah, sudah kelihatan belum? Paparannya enggak ya?
Belum.
Berarti tadi harus di berarti tadi Zoom meeting saya harus saya share lagi nih. Tadi terputus Pak, mohon maaf. Ini tadi ya, Pak Wali di kota, Pak Ani yang terlambat, kalau ini distrik yang terlambat. Oke. Ya. Nah, saya ingin supaya masyarakat Sulawesi Selatan, khususnya teman-teman kampus ini belajar dari LRT Jabodebek. Dulu saya ingat waktu tahun 2016 saya mengajak mahasiswa dari Unhas itu melalui Pak Profesor Rudi Jamaluddin, coba dibawa mahasiswa kita belajar LRT, MRT. Waktu itu saya PPK LRT. Karena saya lihat dari beberapa perguruan tinggi, misalnya Undip, ITS, Brawijaya, berbondong-bondong datang ke Jakarta untuk belajar bagaimana teknologi LRT yang sedang dikembangkan. Nah, kita tidak perlu menunggu sampai Makassar macet seperti halnya Jakarta ya, untuk bisa membangun LRT karena sangat mahal biayanya. Selain lahannya sudah tidak ada, sulit juga membangun di tengah kota. Bayangkan sekarang LRT Jabodebek itu bekerjanya di tengah malam, ya, jam 10 malam sampai jam 4 subuh bekerjanya. Sehingga untuk membangun LRT Jabodebek yang 44 km itu sudah 5 tahun belum selesai. Mudah-mudahan tahun depan sudah dioperasikan. Jadi sekedar mengingatkan saja bahwa LRT Jabodebek itu walaupun tadi berada di pinggir tol, itu butuh waktu saya 3 tahun untuk membebaskan lahannya. Dan yang terakhir itu deponya di Bekasi Timur 12 hektar luasnya, itu baru beberapa bulan terakhir itu bebas. Sehingga yang membuat LRT Jabodebek terlambat selesai itu karena pembebasan lahan. Nah, apa sih manfaat yang diperoleh dalam pembangunan LRT? Kita belajar dari LRT karena LRT baru ada di Jakarta dan saya paparkan ini adalah yang Jabodebek. Ya. Ini kalau kita lihat kalau dari Jatimulya ini Bekasi Timur ya. Saya berikan nama di Jatimulya karena waktu itu masyarakat Jawa Barat kan tadinya Bekasi Timur, dia bilang oh ini masuk Kabupaten Bekasi Pak, masa kami tidak kebagian cuma stasiunnya saja, nggak ada namanya, sehingga saya ganti dengan Jatimulya. Itu dari Jatimulya ke Duku Atas, ya jalan di Jenderal Sudirman itu kalau kita yang naik mobil pribadi itu 2 sampai 3 jam perjalanan. Tapi dalam skenario ini cukup ditempuh dengan 45 menit. Ya. Sebagai informasi bahwa di Jatimulya ini juga deponya LRT Jabodebek, sehingga kontrolnya ada di situ. Kemudian dari Cibubur yang jaraknya 26 kilo, itu persisnya di Pramuka ini, itu sama 2 sampai 3 jam. Ya kebetulan saya tinggal di daerah sana. Dan kalau dioperasikan nanti ini cukup 39 menit atau 40 menit. Jadi besar sekali manfaatnya dari aspek waktu yang kita peroleh. Ya. Nah pertanyaannya, untuk mendapatkan transportasi yang tadi bisa merubah waktu perjalanan yang tadi 2 sampai 3 jam menjadi beberapa menit, bagaimana mewujudkan? Tentu tidak boleh kita dan tidak bisa kita dengan sendiri saja. Kita berpikir sendiri, berjuang sendiri. Ternyata untuk membangun LRT Jabodebek itu ya yang diatur melalui 3 Perpres, ya, Perpres 98, kemudian dirubah jadi 65, kemudian ada Perpres yang terbaru lagi. Itu melibatkan banyak pihak. Mulai dari Kementerian Perhubungan, Kementerian BUMN, Kementerian PUPR, Kementerian Agraria, Kementerian Keuangan, dan yang paling penting adalah pemerintah daerah. Ya, ada DKI, Jawa Barat, Kota Bekasi, Bogor, Depok. Karena ya bicara Minasata tentu ya tadi minimal Maros, Suku Minasa, Makassar, Takalar, 4 kota Pak yang dihubungkan. Sehingga harus berkolaborasi dan harus satu kelembagaan khusus untuk mewujudkan itu. Nah ini saya contoh LRT Jabodebek yang dibangun prasarananya oleh Adikarya, kemudian dioperasikan oleh PT Kereta Api dengan diberikan konsesi oleh Kementerian Perhubungan selama 50 tahun. Jadi kita harus mulai dari situ. Jadi kelembagaannya, stakeholdernya juga harus kita identifikasi. Tidak sekedar tadi teknologi itu dan perencanaan. Nah, tadi ini sudah disampaikan bahwa ini diatur oleh 3 Perpres. Ini mungkin proyek paling ribet di Indonesia karena diatur dengan 3 Perpres. Diatur Perpres, panjangnya itu ada 6 lintas, panjangnya sekitar 83 km dan yang dibangun sekarang baru 44 km sampai Cibubur. Ya. Nanti akan diteruskan ke Bogor dan nanti di dalam kota juga ada yang Grogol dan ada yang Senayan. Nah ini saya, di dalam membangun ini banyak sekali keterlibatan para konsultan maupun dari luar dan juga dari dalam negeri. Kalau studi kasus untuk LRT Jabodebek ini, kalau kita lihat, ya, itu desain integratornya dari Sistra Prancis, sipilnya khususnya untuk USEP, ya, USEP Girder dari Sistra, kemudian sipilnya didukung oleh ITB, ITS, kemudian trackworknya Sistra Railway System, kemudian stasiun, kemudian depo, dan lain-lain. Jadi banyak pihak yang terlibat di dalamnya. Kemudian tadi pagi sudah disampaikan oleh Direktur Persarana, saya tidak ulang lagi. Saya ingin memberikan gambaran saja, karena ini sesuatu hal yang baru mungkin kalau di Makassar nanti, bahwa yang sebelah kiri, gambar sebelah kiri ini diterapkan di LRT Jabodebek. Ya, LRT Jabodebek dengan konsep USEP Girder. Kalau yang di tengah ini diterapkan di LRT Sumatera Selatan dengan kontraktornya Waskita. Ya. Kemudian sebelah kanan ini yang LRT Jakarta tadi, kontraktornya dari Wika dan termasuk juga MRT yang layak, ya, jadi pakai box. Nah, ini kita lihat perbedaan elevasinya, tentu ada efisiensi biaya di situ. Jadi mengapa dipilih seperti itu, tentu ada reason-nya. Gitu. Ini ke waktu awal-awal ini foto di Cibubur karena dimulai Cibubur memasang girdernya. Ya, ini tadi LRB, ya, karet, sudah disampaikan. Saya ingin ini Pak, ini kita bangun di samping jalan tol. Ya. Sangat mengganggu lalu lintas. Oleh karena itu waktu kerjanya di atas jam 10. Dan paling lambat itu setengah 5, bahkan jam 4 bekerjanya di RW Jalan Tol. Kenapa RW Jalan Tol? Karena itu sudah dikuasai pemerintah. Mungkin kalau membebaskan lahan dari masyarakat, mungkin belum selesai sampai sekarang. Pembebasan lahannya 44 kilo. Tapi karena ini menggunakan RW Jalan Tol, maka ini jauh lebih cepat. Ini saya tidak sampaikan. Ini sedikit bahwa konsep USEP ini dilengkapi di samping kiri itu ada semacam cookingnya, itu jalur evakuasi kalau misalnya kereta mogok di tengah jalan, jadi bisa keluar dari situ. Jadi aspek-aspek keselamatan. Kemudian juga menggunakan trail, kemudian ini pemutus arus. Tadi sudah disampaikan pagi-pagi tadi Pak Direktur. Ini teknologinya, sistem persinyalannya itu moving block, ya, headway-nya 3 sampai 6 menit. Sebetulnya CBTC itu bisa sampai 2 menit, tetapi untuk tidak memperberat sistemnya, ya, ditentukan 3 menit. Jadi Jadi untuk dari Cawang ke Duku Atas itu 3 menit, dari Bekasi 6 menit, dari Cibubur juga 6 menit. Nah, terkait dengan sistem operasinya, ini menggunakan GOA 3, driverless, di atas 1 level dari teknologi yang digunakan oleh MRT sekarang. Kemudian ini sedikit gambaran saja. Saya kira itu yang saya ingin sampaikan. Jadi intinya bahwa kalau kita ingin membangun sistem transportasi perkotaan, betul-betul harus dibicarakan dengan matang dengan beberapa stakeholder yang terkait, sehingga persoalan-persoalan sosial khususnya dalam pengadaan tanah itu bisa kita reduksi. Mungkin ini saja share saya terkait dengan perkotaan ini. Sebagai penutup, saya ingin menyampaikan bahwa Makassar Parepare saat ini sudah ada beberapa yang sudah selesai, paling tidak sudah ada 42 km yang jalur utamanya ditambah dengan sidingnya sekitar 5 km sehingga 47 km. Saat ini kami sedang membangun sambungannya dari Mandalika sampai tadi stasiun Marupa 60 km dan saat ini sudah progresnya mencapai 70%. Semoga bisa kami selesaikan paling lambat mungkin Maret 2022 sehingga kita bisa mengoperasikan secara bertahap. Itu mungkin dari saya. Terima kasih. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Terima kasih banyak atas paparannya ya, menarik. Kita paling tidak ini sudah ada gambaran ya, proyek-proyek yang di-develop oleh Kementerian Perhubungan, baik proyek yang ada di Sulsel saat ini ya, lebih spesifik pada proyek Makassar Parepare Intercity, dengan juga rencana pengembangan Maminasata Urban Railway. Nah, nanti arahnya apakah LRT atau MRT tentunya membutuhkan kajian-kajian yang lebih mendalam lagi ya, di fase pre-feasibility study, feasibility study, dan staging selanjutnya gitu. Kemudian tadi Pak speaker juga sudah, Pak Jumardi sudah memberikan lessons learned sedikit terkait LRT Jabodebek yang memang sampai saat ini masih under construction dan insya Allah saya rasa kedepannya seperti yang disampaikan Pak Jumardi harusnya tahun depan sudah bisa dioperasikan dan bisa dinikmati oleh warga di kawasan Jabodebek. Kira-kira itu ya. Kemudian kita lanjut ke sesi pembicara keempat. Semoga ya, ini pembicara keempatnya sudah hadir, atau pembicara kelima, sorry. Speaker, the fifth speaker from SMAC International, hopefully Ibu Karen Atkinson is already here, so she can present the concept of transit-oriented development best practice. So we have several experience across the globe, and mostly our projects dealing with this urban railway, MRT, LRT, as well as TOD. Ibu Karen, are you already here or not yet ya? Mungkin panitia bisa dilihat ada nama Karen Atkinson di Zoom kita. Belum ya? Apabila belum, oke, mungkin kita bisa lanjut babakan tanya jawab aja dulu. Ini untuk sesi Pak Jumardi dan pembicara pertama tadi dari Yamada-san. Silakan. Ya, jadi nggak perlu nulis di chat room Pak, bisa langsung angkat tangan dan langsung mengemukakan pertanyaan. Kami persilahkan. Pak Dedi. Pak Dedi, if you have questions, please, time is yours.
Oke, baik. Terima kasih Pak Habibie. Saya Muhammad Didi Gamawan, kebetulan saya dari KCIC, berdinas di KCIC sekarang. Menarik tadi penjelasan Pak Jumardi bahwa kita sudah, mohon maaf, apakah suara saya jelas Pak? Mohon maaf.
Ya, sangat jelas Pak.
Oke, baik.
Jelas, Pak.
Ya, terkait dengan tadi CBTC, saya ingin coba menanyakan apakah ada rencana dari pemerintah dengan meningkatnya tingkat teknologi dari persinyalan dan telekomunikasi kita ini, bahwa apakah ada rencana pemerintah untuk mempatenkan frekuensi tersendiri, bahwa ini adalah frekuensinya kereta api. Mengingat kami contoh di KCIC agak bermasalah di GSMR, dan itu bermain di frekuensi 7,5 sampai dengan 8,5. Nah, apakah memang ada rencana nanti dari pemerintah untuk memfasilitasi hal ini? Jadi kita Kementerian Perhubungan mempunyai frekuensi tersendiri, dia tidak mengganggu lagi frekuensi yang dipakai oleh pihak GSM atau provider GSM lainnya. Kenapa ini jadi penting? Karena ini menjadi bagian dari safety dari perjalanan sistem kereta api tersebut sendiri, baik itu di komuter maupun nanti di high speed. Itu saja Pak Jumardi, terima kasih Pak.
Ya,
terima kasih Pak.
Langsung aja Pak Jumardi.
Ya, terima kasih Pak. Sebetulnya saya tidak mendalami tentang ini, tapi waktu saya di Direktorat Prasarana, kebetulan sempat sebagai Kasubdit Kelaikan Fasilitas Operasi membina persinyalan ini. Memang kita sudah pernah komunikasi dengan Kementerian Komunikasi dan Informasi, bicara tentang bagaimana frekuensi kereta api ini dapat diberikan tersendiri, tapi ini masih dalam pembahasan. Saya kira kalau memang ini sangat dibutuhkan ke depan, ya ada baiknya memang kita akan minta khusus dari Kementerian Komunikasi dan Informasi. Itu Pak.
Baik Pak, terima kasih Pak.
Okay, second question please.
Assalamualaikum Pak Jumardi. Saya Kunci Pak. Jadi yang saya pahami ya Pak, untuk specification atau feasibility study daripada LRT Jabodetabek itu kan menggunakan software rail attracts Pak ya. Iya gitu ya Pak Jumardi ya, Pak Jumardi. Dari software rail attracts itu beberapa parameter dimasukkan seperti jumlah penumpang, kemudian ketersediaan listrik, besaran dan lain sebagainya, sehingga dijumpai suatu kelayakan secara teknika dan keekonomisan daripada LRT Jabodetabek. Nah, saya sebenarnya menunggu Pak untuk hal yang sama dilakukan untuk LRT Kota Makassar dengan menggunakan simulasi rail attracts. Akan dijumpai parameter-parameter sehingga tidak terulang kejadian, misalnya, mohon maaf, kejadian di Palembang dan kejadian di Kelapa Gading. Sehingga kata gini Pak, sederhananya kami awam berpikir kalau Jabodetabek ingin dibuat LRT, tutup mata Pak, karena hitungan kerugian memakai kendaraan pribadi itu setiap tahun 28 triliun. Tutup mata Pak kita untuk mendesain LRT di Jabodetabek. Tapi kalau di Kota Makassar, itu satu hal yang berbeda. Kita harus berpikir 3-4 kali. Dan yang sangat membantu pemahaman awam saya adalah penggunaan software rail attracts. Yang saat ini saya nggak lihat siapa yang menampilkan itu Pak. Mohon petunjuk Pak Jumardi. Terima kasih. Waalaikumsalam warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Ini memang sangat penting Pak. Oleh karena itu kita harus mematangkan perencanaan kita kalau kita mau berkomitmen, ya pemerintah daerah khususnya sudah memutuskan bahwa akan membangun LRT karena ini bukan suatu infrastruktur yang murah. Gitu. Kalau sebagai gambaran saja bahwa LRT Jabodebek itu kalau semuanya all cost ya itu hampir 500 miliar per kilometer. Strukturnya sendiri itu sekitar 275 miliar per kilometer. Dan yang lain. Palembang hampir sama. Tapi persoalannya kan demandnya kecil sekali. Kuncinya adalah bagaimana kita tadi Pak disampaikan bahwa LRT kereta itu tidak bisa berdiri sendiri, harus terintegrasi dengan moda lain karena LRT tidak bisa tidak fleksibel untuk bisa menjemput orang sampai di depan rumahnya. Sekarang kan transportasi itu sudah sampai di depan rumah. Jadi tapi bukan berarti bahwa kita tidak bisa membangun LRT di Makassar. Kita harus memikirkan memang bagaimana integrasinya itu. Jangan sampai sama dengan LRT Jakarta. Kita komit dulu waktu bicara LRT Jabodebek, kami tidak bangun itu stasiun yang samping kali karena LRT Jakpro dari Kelapa Gading itu rencananya sampai Jalan Jenderal Sudirman juga. Tapi ternyata hanya 4,5 kilo, mana bisa dia survive ya. Satu-satunya ya harus dipanjangkan sehingga economic scale-nya itu masuk.
Ya itu Pak Jubandi, maksud saya feasibility study itu dibuat semacam simulasi algoritma Pak, sehingga keputusan untuk meng-kick off proyek ini itu benar-benar atas hitungan yang holistik. Setahu pemahaman saya, Rail Attrax mampu melakukan itu Pak, dan memasukkan input-input sosioekonomi dan bukan hanya teknikal. Nah ini yang sebenarnya yang harus disampaikan kepada pemda-pemda, bahwa secara teknologi sebenarnya LRT itu kan di luar sana sudah selesai, bukan selesai Pak, sudah mature Pak. Jadi kalau kita bicara teknologi LRT di forum ini, itu sudah mature. Kita bahkan seperti Saudi Arabia dengan Spanyol tren itu kan tutup mata aja karena memang dia sultan. Dia bisa mengimpor 100% teknologi kereta api untuk 70 derajat Celcius dari Spanyol. Tapi dia punya passenger itu umroh haji, selesai tutup mata. Nah, untuk Pemda daerah di luar Jabodetabek, ini kita butuh kehati-hatian karena kita bukan negara sultan. Karena kita bukan negara sultan, saya membaca bahwa Rail Attrax itu sangat membantu untuk pemda-pemda itu dan terutama Departemen Perhubungan memutuskan bahwa proyek ini laik atau tidak. Demikian pemahaman awam saya, Pak. Terima kasih moderator. Assalamualaikum warahmatullahi wabarakatuh.
Ya, Pak Jumardi masih mau menjawab atau gimana Pak?
Saya kira sepakat Pak untuk optimasi. Jadi sekarang kalau kita udah coba dijadikan satu lintas dulu lah, ya kan? Tadi saya gambarkan tadi bagaimana Maminasata Urban Rail, tapi kan belum dimulai. Coba dimulai. Saya pada beberapa kesempatan di depan teman-teman di Pemda Kota Makassar waktu itu sama di subnya, saya bilang coba dimulai melakukan kajian satu penggal saja dari beberapa itu. Mana yang paling urgent saat ini kita coba.
Ya, saya rasa itu jawabannya ya Pak Jumardi. Memang sepakat ya, tentunya kan untuk segala proyek ya, investasi tentunya harus melalui kajian-kajian yang holistik, komprehensif gitu, dan melalui proper staging yang kita bisa sepakati bersama sehingga proyeknya itu bisa bankable, bisa kita jual ke international finance institution, bisa kita jual ke investor dan seterusnya. Ya, oke, let's move up to the fifth speaker, the fifth session. We have Karen Atkinson from SMAC International. She is our Deputy Chief Operating Officer for Southeast Asia region, and she's also in charge as Regional Manager for SMAC Indonesia. She's going to touch more on the transit-oriented development best practice, what we have around the globe, lessons learned of this kind of infrastructure. Yeah, not only the railway system itself, not only the MRT, the LRT, but the concept of TOD also very, very important to ensure that the economical of the investment can be met. Okay, Karen, time is yours.
Thank you, Habibi. Can you hear me okay?
Yes, we can.
Okay, let me see if I can share my screen so you can see my slides.
Yes, we can.
Okay, just make it the slide mode. Okay?
Okay.
Great. Thank you so much for inviting me to speak today. I hope you can hear me okay. Please stop me if you can't hear or need me to repeat something. So, as Habibi just said, I'm going to cover a little bit about transit-orientated development and what's some international best practice in that. I think, you know, it's one thing to build a railway line, but you have to make sure that it's integrated into the city and provides the most optimal value for all the citizens that it's designed to serve. So I'm going to share a little with you from Singapore and from Australia on some of the lessons that we have learned. So just to start with, as an introduction to our company, so SMEC is an international consultant from Australia, which is owned by Sabana Jurong Group from Singapore. And we have some sister companies that also work in the rail sector, in SAA, who are an architectural firm, and Robert Bird Group, who are specialist structural engineers. SMEC has a long history as a company. We were founded in 1949 to deliver the Snowy Mountain hydroelectric project in Australia. And in 1970, we delivered our first project in Indonesia. So we've been operating on projects in Indonesia ever since 1970, which we're very proud of. In 92, we founded PT SMEC Denka, the local associate company, and we've been involved on a number of notable projects, including from 2008 to 2018, we ran the Indie program funded by Australian aid. So we're very proud of our history here in Indonesia. And just a couple of the projects we've been involved with, we assisted with the construction supervision and review of Palembang LRT, which is a beautiful facility there. We're also currently assisting with the Jabodetabek LRT, which I think we've had some discussion on already. But also in the transit-orientated development as Sabana Jurong, we've also done some projects around helping look at what does TOD mean for the new high-speed rail project, and particularly at the Welini station. So we did some work both for KCIC on the area immediately around the station, but then also, if my slides will move on, hasn't got stuck, oh, hang on. We also did some work in the broader area around that TOD there at Welini as well. So, you know, I think we're talking about TOD. What is that? What does that mean? And it can mean a lot of different things to different people. But really it's around building a development around a transport hub that could be rail, it could be LRT, could be commuter rail, could be high-speed rail, could even be BRT, something like that. But it's something that makes the transit station highly accessible to a mix of residential, retail, commercial, and community spaces around that station. And so it really encourages high quality public space, and it also encourages medium and high density development in that area and encourages use of the public transport. So why do we need TOD? I think we're all aware that some of the mega cities around the world are already very dense. And if everybody in those cities tried to move around with their own vehicle, it would be hugely congested and not practical. So I think for the context of Indonesia, where some cities are already very densely crowded and need the public transport, some are not now, but will be in future, we need to start now to think about what do those spaces want to be like in future, and how will we cater for people's transport needs. So there's 5 factors that make global urban mobility really successful. The first is availability. So, you know, the services have to be there, they have to be frequent, they have to be easily accessible to encourage people to use them. They have to be affordable. Obviously, if the price of the ticket is too high, people are not going to use the service and it won't move the cars or the motorbikes off of the road. It has to be efficient. So that means efficient in that the service is quite fast, but also efficient in how do I get to the station? If I have to drive my car to the station, can I park there? How do I get my ticket? You know, can I just tap with that electronic card? Those kinds of things make a system efficient. We have to look at the convenience, again, all those similar areas. And we have to look at the sustainability, which can mean safety, it can mean, is it green, you know, reduces carbon footprint, can mean a few things in sustainability, but important for us to consider all of those factors. And so we can see that McKinsey has done some ranking of different cities and how they rate. I think not surprisingly, Singapore comes the top city in terms of urban mobility. You know, we all go to Singapore often and we can see that. But I think interesting when we look at some of the factors, the difference between the new cities and the old cities. So when you look at, for instance, availability, the grey area, Paris, London, New York, and Madrid come up the top 4 because they're old cities, they've been building their rail lines for a very long time, and so they have a very good network. But then on the flip side, when you look at sustainability, New York is 12th, very low score on sustainability because they have very old infrastructure that they haven't spent the money upgrading. So it's not so safe, not so green, those things. London still comes out 4th on sustainability. So obviously they've been doing a lot of work to the tube network there. So, you know, we really hope that in the future, maybe we will see some Indonesian cities in these top rankings of global cities for urban mobility. So just a case study for Singapore. So Singapore LTA Master Plan says that they want a Singapore that is a 45-minute city with 20-minute towns in 2040. So that's a pretty bold statement. They want it to be no more than 45 minutes to get from anywhere in Singapore to anywhere else in Singapore. And they want kind of sub-zones within Singapore where people can access all of the services that they need within 20 minutes. So they're looking at a number of things as part of this. They're looking at walking and riding and cycling as part of that mix. They're looking at transport for all, and they're looking at healthier lives and safer journeys as part of how they want to provide that. So when you look at Singapore, they've identified specific zones because they know they can't concentrate everything just in downtown Singapore. They have to create community hubs elsewhere to create diversity, and so that not everybody is always coming into the city and going out of the city. They want to create mini hubs in other places, and they're actively planning to do this. So one example of that is the GEM development, which is Jurong East. And this is one where they've very specifically designed for a lot of these factors. So when you consider TOD planning, you have to look at a whole of site approach and integrate the transport hub into the existing urban contexts and community amenities. You have to augment the wayfinding so that people are able to find their way from one part of the site to another. You have to make it very convenient for people to access facilities. You want to build a community, so you want to make these places places that are enjoyable for people to go to, that people want to go to, and that are an asset to the community that they can be proud of. And of course, you want to enhance value. And you know, when we're talking about enhancing value, that's you know, partly for the public, but also you're trying to encourage private developers to put their money into office spaces, retail spaces, residential spaces around the station. So you're trying to enhance value for those developers and commercial interests so that they will build high quality resources there as well. You also need to think about the stakeholders. So you have to balance expectations. Stakeholders can include, of course, the railway owners, you know, often a government department. It will include those commercial interests that I just talked about. It will include the public that have to use the space. You know, we have to think about emergency services that might have to access the space. You know, so many different stakeholders that we need to consult with. And we need to optimize the transport space. So if we have a site, we don't want it to be completely taken up with the station such that there is no space for the other commercial developments or other facilities. And coherent identity, again, this is coming into putting some rules around the architecture, the planning, the look and feel of the space so that it feels like one area. So the GEM piece we'll just take a look at. So this is the proposed Jurong Lake District Master Plan, and the station is where you can see the little red box there. And you can see how they're thinking about how to link that station through to these beautiful public spaces that they're creating to try and attract people into that area and make this a very easy to access and attractive place for people to go. Also, when we look down then in more detail, we can see that around the GEM station, there are a number of community facilities. So there's a hospital, there's a learning institute, there's some retail with the big box and a JQ, there's a library, you know, and so they're really thinking about how do they tie together public amenity, and commercial space. So this is a photo view, and you can see overlaid here all of those different uses and how they're linking those together. And again, this slide just shows in even more detail how they think about the actual pedestrian flow through the site and through the building to achieve that connectivity. So I think the gem is just one site that we can look at, but you can see from this chart how the thinking has shifted in Singapore over time as they've learned lessons. So some of the early stations that they built, such as the Atrium Adobe Gore, you can see that they incorporated there the MRT, the bus and the taxi, but they weren't really thinking about these public spaces. Whereas you come into the more later developments and they're thinking much more carefully about how do they integrate the libraries, the community centres, the town plaza, the green space into those stations so that everything's more connected. So I think there's some very good lessons that we can learn there from Singapore in terms of not just about... Sorry, someone has some questions?
Okay, we may just continue.
Okay,
yeah.
Thank you. So then we go on to the next example, which is Cross River Rail in Brisbane. And this is a project that's been in planning for a long, long time. I remember it was being discussed when I lived in Brisbane, more than 10 years ago now. But finally, this project is being implemented. In the past, Brisbane has had commuter rail, particularly from the south, from the Gold Coast, and from the north, from the Sunshine Coast, but not much in terms of MRT or LRT. What Brisbane has had is a lot of BRT, bus rapid transit. So this is the first real metro rail in Brisbane. And the site, one of the sites that we were looking at was Woolloongabba, but before we get to that, so this is just concept image for Roma Street Station in Brisbane, and Roma Street is right in the middle of the city, and so you can see that the design concept for this has a very urban feel to it. It's in the middle of the downtown area with lots of high-rises around it. But it's still very open, attractive space. In contrast, this is Boggo Road Station, and Boggo Road is a little bit further out of Brisbane. And so you see they've gone for a much different look and feel to the station. It's more open, it's more green, just to reflect the character of that area. But that talks a little bit to what I was saying earlier about you can make really attractive TOD by making each station quite unique to the area that it's in, rather than cookie cutter, the same station design everywhere. So the lessons I think from Cross River Rail is that, you know, there's a lot of planning that's gone into this, you know, and also they're thinking into the future with how they're looking at how will this rail line change mobility patterns across Brisbane. So this is an aerial view of the Woolloongabba precinct. People who are cricket fans might have heard of Woolloongabba, or the AFL is played there. But the Woolloongabba site is quite close to Brisbane city centre, but at the moment it's very low density development. So you can see from the aerial photo, all of the buildings are quite low rise, you know, 2 stories, 3 stories, 4 stories, lots of green space, big roads. It's not dense at all. But given that it's quite close to the city centre, that doesn't seem like a very smart use of the land. So for this site, we actually did some modelling, and we looked at different development scenarios and said, well, look, you know, given that this station is coming in, what will the density of this site look like in future? And so under some of the development scenarios, maybe the population, the equivalent population of this area could be 3,500. Or, you know, if we develop this a little differently, it could be 7,300 equivalent population on this site. And so it's important to think about how the station and the transport infrastructure that you're putting in will change the density of those sites in future, because that has impact on many more things than just the transport infrastructure. So this graph here is actually looking at water demand, which we don't normally think of when we're talking about rail design. But it shows that as the number of morning trips, so this is AM, morning trips, and the peak water demand, you know, obviously there's more people coming into the area, the water demand is higher, but the water demand also changes based on the mix of types of development. So on the left-hand side here on the blue line, we have 100% commercial and 0% residential, whereas on the far side, we have 0% commercial and 100% residential. And so that also changes the water mix and the water demand in that area. So when we're looking at providing infrastructure for a city, we need to look not just at the transport infrastructure, but also how does that change the density and the other infrastructure needs of that area. So, you know, I think a number of different things to consider. Also in Brisbane, given that it is such a car-based culture in Brisbane, a lot of people might use the train, but they might drive to the station and then take the train for the last portion of their journey. So considering things like car parking and you know, those intermodal journeys is very important as well. So this kind of just summarizes again around that Woolloongabba site, where we really looked at whole of life cycle, how the demand will change, how we could provide flexibility in the design of that Woolloongabba site to just make it flexible based on different growth demand scenarios. So I think to summarise, best practice in TOD requires long-term forward-thinking planning and a precinct concept of design that considers the population, the infrastructure and connection of public amenities. We need to think about the 5 factors that make urban mobility successful: the availability, affordability, efficiency, convenience and sustainability. We need to think about designing for whole of site, think about designing for the wayfinding, building communities, enhancing value, and also considering the stakeholders and how do we balance their expectation, optimise that transport space and deliver a cohesive identity for the area, so that as soon as you get off the train, you know where you are just by the look and the feel of the place. And that's the end of my presentation. Thank you, everybody.
Okay. Thank you, Karen, for this 20-25 minutes presentation. Now we all can get more knowledge in this TOD concept. There are some conclusions, not really conclusions, but something that I can write here on Karen's presentation regarding the 5 factors of success for the global urban mobility that was explained, and then the TOD planning itself, the alignment of stakeholders for this kind of projects. And Karen also presented some of the projects SMAC has done in Australia and Singapore. And last but not least, we have best practice of TOD in the last presentation. Okay, actually we are waiting for the 5th speaker to join us, but I haven't seen him in my screen, so I think we can just open the question and answer session, yeah, with Karen and the other previous speakers. So please free to raise up your hands and asking questions. Please. Pak Kristianto Usman.
Yeah. Thank you, Pak Habibie Rajab. Hi, Karen. Good afternoon. I'm Kristianto from Lampung Railway Center. I'm former researcher in the University of Birmingham. Very interesting presentation about the TOD. My question is, if the TOD planning is being developed and that you find that the revenue stream of the TOD is not adequate, what should we do? Do we should replanning, or we also consider TOD to combine with another mechanism, for example, LVC, land value capture, or something else? Thank you.
So the question is around what if the plan for the TOD doesn't go according to plan?
For example, there is some excessive changing in the circumstances. For example, during the pandemic, or the traffic is extremely down, and people said, it cannot be possible to build the TOD, something like that. What should we do?
Look, I mean, you know, and there's things that happen that change people's behavior and habits, and the pandemic is a classic example. You know, I think people are much more afraid to take public transport right now, and it will take some time for that to change again, definitely. So I think when you put in place the plan for your TOD, you have to plan some flexibility, and so you have to model those different scenarios and say, well, okay, what if we get growth this much, and then what if we get this much growth? You know, can we deal with both of those scenarios? You know, and there's some things that we can predict might vary a little bit, but of course there are always things that we can't predict, and so sometimes it just doesn't turn out the way you planned, and you have to do a revamp.
Okay.
Yeah.
Thank you. I'm totally agree. We are in some cases we are also using a probabilistic approach. Then we do some simulation to do the case, something like that. Thank you very much, Karen. Much appreciated. Thank you, Pak Habibie.
Okay, thank you, Pak, pertanyaannya. Okay, the second questions we found from the chat room from Pak Dedi Gamawan. Pak Dedi Gamawan is working for KCIC ya. Ini Pak Alan Tandiono ya, temannya Pak Alan ya. So friend of Pak Alan. Pak Alan previously worked with us ya. Okay, the question is because this concept of TOD is quite new in Indonesia, this last 10 years, we can say, which one must be prepared first transportation builds the TOD or the TOD which will create transportation?
Yeah, look, and that's an interesting question. And it probably depends a little bit on the context. So I think if you're building in an existing urban area, say like the MRT in Jakarta, or you know, if we build MRT or LRT in other existing cities, then I think consideration of the TOD is very important early, because it will affect how you actually design the station. Whereas a different scenario might be something like the Welini project, where really there's not much there at the moment, and the whole point of building the station is to create a new urban centre around it. You know, I think in which case you can maybe say, well, okay, we're going to put the station here, but then you still have to follow that up with a plan for what do you want that area to look like. Because if there's not really much of a development plan, you can end up with the wrong things in the wrong places, if that makes sense, because obviously the land closest to the station is always more valuable and more attractive for private development. So you need to, if you want to have some of those public amenities included in the TOD, you have to plan that early. Otherwise, you could end up selling all of the land around the station to private developers, which would be great for the revenue stream, but maybe you're not quite achieving the social objectives that you want. So I think it's always important to consider the development plan early, but perhaps the timing can be a little bit different depending on whether it's brownfield or greenfield site. I hope that makes sense, Pak Dede.
Okay. Yeah. Okay, let's move to the third question. Either Pak Ansar Rahman or Pak Daeng. I think Pak Ansar will have the turn. Silakan Pak Ansar.
Silakan Kanda.
Silakan Kanda. You are still mute. Can you please unmute, Pak Ansar?
Okay, thank you for this opportunity. Your presentation is very nice for us. I just have one simple question. Just now you have shown us a global urban mobility where there are 5 success factors: availability, affordability, efficiency, confidence, sustainability. You mentioned some big cities in the world, but there is no Jakarta in your analysis. What do you think about these 5 factors Jakarta? Are they good enough? And do you have an analysis of the cities of Makassar, Maros, Goa, and Takara, ring cities in South Sulawesi? Ring big cities actually in South Sulawesi. Yes. That to be able to implement the concept of urban mobility. And how about the TOD aspect is for the 5 cities in South Sulawesi?
Thank you for the question, Pat. So what do I think of Jakarta? Now that's an interesting question, isn't it? Jakarta is the classic problem of building an MRT after the city is already built. And I think perhaps because there is not good examples of MRT before the current Jakarta line, people didn't really know what it would look like or how it would work in Indonesia. Because whilst there's some global rules on TOD, you have to adapt things for local culture and local practice. So, for instance, I used the section of MRT before the pandemic. I used the section of MRT sort of from Block M up to the north quite a lot, and it's a great system. But it's such a shame that some of the malls and the facilities didn't choose to connect in, and I think maybe they were nervous that people wouldn't use the train, or the people who used the train wouldn't shop in their shopping centres, or I don't know. But that's a real shame and a missed opportunity, and I really hope that sometime in the future they say, actually, this is a great facility and we want to hook up, because I think then that will really catalyse the start of proper TOD for Indonesia. So that's the Jakarta scenario. Unfortunately, I have not yet visited Makassar. I will definitely come see you guys one day. So a little bit hard for me to comment directly. But it's hard. I've been to Palembang and I've ridden the train there. And there's some sections where, because we were trying to build the LRT along the existing streets, the alignment is quite suboptimal. I think, everybody can recognise, just because it had to be, because we had to build on existing streets. And, when you're retrofitting like that, it is really hard. It really is. But I think then the plan is you have to have a long-term view. And so you have to say, well, okay, in the short term, maybe we have to compromise because we have these existing constraints. But over time, how can we change maybe the zoning of some sites, or, the development mix, so that in the longer term, we actually end up with the TOD that we want and that the city deserves. I hope that helps.
Thank you for your nice answering. I think you should have a lot of discussion about this.
Yes. Thank you.
Yep. Pak Anca, when you are in Jakarta, we can have like a coffee session in Block M area. Our office is in Block M area. It is not far away from your office, I guess. Yeah.
Okay.
Yeah. Okay.
Thank you very much.
Thank you, Pak Ansar. I think the last question for Ibu Karen, Pak Daeng Konci, you still want to have questions? Pak Daeng? Any questions from other participants?
Yes, if there is no, I would like to ask question.
Yeah, Pak Ilham, our committee would like to ask questions.
I Dan Konci. Now I'm allowed to have a direct conversation with you. Sorry, Pak Habibie.
Silakan, Pak.
My position is unmute. Hi, Karen. Interesting presentation regarding TOD. What I would like to emphasize like this: if you see urban transportation in Japan, especially during busy office hours, women and men, in terms of crowded passenger, touching each other. In Japan, there is no issue such thing. Nobody scream, everybody keep quiet, everybody will understanding. Now, I want to ask you regarding your kind of point of view in terms of, we can say that social, cultural, religion, if I could say like that, especially in this country or Muslim country. Yeah. In Indonesia, especially for example, in Makassar, there's a quite different culture between guys or women in Jabodetabek and women in Makassar. In Jabodetabek, it's quite flexible. It's quite, I think a woman will understand if there is a crowded passengers, woman and woman touching each other in terms of sensitivity anatomy. And if you see the commuter line, in the beginning, there is no such thing, woman carrier, There's no such thing in the beginning. It's all passenger, woman, but don't matter. Because the push of the woman on human rights, organization, the asking government at that time to provide carriers for women. Also in Transjakarta. In the beginning, there's no such thing, seat for women. It's all for passengers. I had seen your presentation. There's no such thing about the social, cultural, religious, urban transportation. What do you think about it?
Okay. Yeah, look, it's an interesting question, Pat, and I think it is very important to be culturally sensitive about how we develop cities and spaces that are meant for the people that live there, right? And I think there are different examples around the world of how cities deal with this. So you're right, in Tokyo, at the rush hour, it's sardines, everybody touching close together, you can't move. And the same in Hong Kong, where I've lived and worked, and Singapore also. So some cultures that's okay, but I have also ridden the metro lines in Delhi, in India, where again, it's a little bit more sensitive. And so there, they do have specific carriages for women. Obviously, if women are comfortable to be in the mixed carriages, then that's okay. But there are specific female carriages on the Delhi metro. So I think it's about being sensitive and just finding the right mix and what works for each city and each context. And like you say, it might be different in Jakarta than in Makassar or maybe some other city as well. So, I think it's, actually on the train, that's one thing. Another thing is at the station. So obviously at the station, you have to get onto the platform to get to the train. And so it's very important that we make the station environment open and inviting and safe, safe for everybody. I think, this is something that's often seen as a criticism of maybe some of the New York metro particularly, but it certainly also used to be true in some of the London Underground, is that the stations were dark and pokey and old and had lots of blind spots, and so they weren't seen as safe spaces. People, nobody felt safe there, men or women. So it's really important in the station design that it's open, there's line of sight or security cameras or, features that make it so there's no crime, no inappropriate behavior, and it's really obvious that if you try to do something like that, people will be watching and you will get caught, So it's about making the station environment safe, as well as providing those women-only carriages on the train where they're needed. And there could be other cultural aspects to build into the TOD. Maybe you want to put some prayer spaces or some things like that. So I think you can make TOD culturally appropriate for wherever it is. You just have to carefully think through what the issues are. I hope that helps, Pat.
Okay, I think we still have some questions from Michelle. Michelle, she's the student of, okay, one of students of engineering faculty. Silakan, Mbak Michelle.
Okay, hello, I'm Michelle Tesman. I'm from mechanical engineering student, and I saw your presentation. It's really great. And I was wondering, would you want to tell me what do I need to prepare in order to develop Indonesia railway technology? Since, as you can see, the technology in Indonesia isn't as sophisticated as the technology in other developed countries like Japan or England. So maybe your opinion might help me to, might lead me to a better future, to a better path. Thank you.
Good question, thank you. So are you talking specifically about your career, or are you talking about the railway technology itself?
Hello, Michelle. Not here.
Can you repeat the question, Mbak Michelle?
She's gone.
She gone?
Mbak Michelle is gone.
Maybe I can say a little bit on both. I think she's there. Michelle.
To unmute myself, and yeah, I'm talking about what should I prepare for my future if I want to develop that kind of technology in my country, because that would be really helpful for me.
Okay.
Thank you.
I think one of the advantages for Indonesia is that there's plenty of examples out in the world now, good and bad, of how to do these things. And so I think the best thing that you can do is to get yourself some experience, maybe start your career with some experience in Indonesia, but then maybe try and go work overseas and get some direct experience yourself from Japan, from Singapore, from UK, wherever. There are so many places that you can learn from these days, and then you can bring those ideas back to Indonesia. I think the beauty is that Indonesia does not have to develop everything from scratch. You can borrow from all over the world. So, we just need people to go out and get the ideas and bring them back. I hope that helps.
Okay. All right. Hi, Karen.
Hi.
How are you? Good?
Very good, thank you.
Yeah, I'm really happy that seems all speakers in place except for Saf. I don't know, we're still waiting for him. But
Habibi, can you just send him the meeting invite again? He said he was just having some trouble logging in.
Yeah, actually we used the same link that we sent to you, but he still could not access the Zoom meeting. So
yeah,
let me send it to him again.
Yeah. Okay.
He said,
anyway,
yeah.
While waiting for Saf, I'm using the opportunity to say hello, and also would like to ask you, I'm fascinated how this TOD is really interconnecting with mode of transportation, different ones, yeah? Like how this, you show the river crossed in Brisbane. I used to ride on the City Cats, actually.
Oh, yes.
Yeah, City Cats, I miss that very much. Anyway, I was thinking if this concept is being applied in some cities in Indonesia that we mostly have rivers, really the concept how the cities overseas, like in Sydney or Brisbane, in other Europe countries, how rivers is actually used mainly for transportation as well. Yeah, just like the City Cat in Brisbane cities. I was wondering if any of the cities in Indonesia is potential to develop this kind of TOD where the mode of having the rail as well as the buses as well as the railway and also connected to the river transportation. Like in Makassar, we have two big rivers in here. We have the Talor River and we have the Jeneberang rivers. Yeah. Although even the canals is actually possible to be developed as the river transportation. Can you comment on this? Is the possibility in Indonesia probably based on the experience in overseas, it's mostly in Australia, for example. Okay, that's my question, Karen.
Thank you. Yeah. Okay, so it's a really good question, and so Brisbane does have an amazing system with the city cats. So for anybody who doesn't know, the city cats are fast catamarans that operate as a ferry service along the Brisbane River. And because the Brisbane River is very winding through the city, it's actually a really useful service, and people use it a lot. I think in the past, ferries were not considered so much as part of public transport because the capacity is less. You know, there's a limit to the number of people that you can fit on a boat and how many boats you can have on the river and where the landing quays are for people to get on and off those ferries. So it's not, in the past it hasn't been considered very strongly, but I think that's changing now. So, you know, Brisbane is a good example of how they've tried to integrate the ferries, particularly with the bus system. So they've tried to make sure that there are bus stops near the ferries so people can take part of the journey by bus and part by ferry, which might be the quickest route. But also in London. So in London, they're also developing the ferries to be a much more usable system and have far higher capacity to be able to move people during those peak hours. So I think any city that has navigable rivers can do it. You know, personally, I think it would be a fantastic idea because it would also then encourage focus on the river health. You know, it's not very nice to take a ferry on a river if it's got trash in it or polluted or whatever. You know, so it encourages the keeping the rivers nice and keeping the rivers as a public space and a public amenity as well as just a transport network. So it can have dual purpose, but it certainly can be very well incorporated if it's thought through in advance, for sure.
So in other words, we actually can develop it if we stick on the principles that the river is clean and everybody is taking care of the
I think if the river's not clean, people won't like to use it.
Which is quite difficult sometimes in Indonesia.
It's very difficult, yes.
Yeah. But it's not impossible. I mean, it's still possible to make it. Like in Jakarta, now rivers are quite clean. I don't know whether if the government of the Jakarta, DKI, is willing to use that when it's clean. I believe in Makassar, if this concept can be a good example of other cities, why not?
Maybe.
They're modding it with other railway.
Yeah, why not? Why not?
Okay, thank you. Thank you, Karen, for the response.
Thank you.
Back to you, moderator.
Okay, thank you. Thank you.
I think we have Saf now, Habibi.
Yeah, Saf is already here. I just saw him in my screen. Yeah, finally. Okay, Saf, you're going to have the last presentation session this afternoon, more on the Northwest Sydney Metro project. I think this is a good lessons learned for us to understand more on the railway project. Okay, Saf, time is yours. You're still on mute, Saf. Can you please unmute? Can the organizing committee make him unmute? Yeah, we can see you, Saf. Unfortunately, we haven't heard your voice. It's not. Yeah. Maybe you can just use the speaker from the laptop. Maybe you have issues with with the headset. We still can't hear you, Seth. Yeah.
We have this.
Yeah, we haven't listened to your voice. Your voice is not coming out. It doesn't come out. No, we cannot hear you. If you can hear me, that
Take off the headset.
the headset should be taken off, and then try to use the speaker from the computer. I think the issue is with the speaker system that you have in your headset. If you can just disconnect the headset and then use the speaker from the laptop, just try. Maybe in Zoom setting, you need to check whether the setting is correct or not. Hmm? Yeah, or maybe Seth, if you can just leave the room first, then reconnect. Let's just try that way.
Yeah. We at least have 30 minutes before we have a finishing. So no worries. Just take a time.
Okay, Steph, can you try? I saw that you already rejoined.
Okay, can you hear me now?
Yes, yes, we can hear you now.
We finally.
Thank you very much.
You finally made it.
Oh my
Thank
God,
you
it's
very
this
much.
Zoom. I'm used to Teams and this Zoom is not functioning as well as I'd like to. Let me just share my screen.
Okay, please.
Can you share screen? One sec.
Yeah, you are granted access to share the screen.
Tell me if you can see this presentation.
Yes, we do. Yeah, we can see.
Excellent. All right, so apologies for this delay. My name is Seb Delaquila. I work for SMEC. I'm the Sydney office. Most of my experience, I've been with SMEC for 5 years, and all my experience has been with the Sydney Metro network. So today I'm here to talk to you just about the basic concepts, what we used, and some of the design aspects that we actually implemented throughout the network. So we're looking at really three designs. So SMEC has been involved with the Sydney Metro project since 2013. What I'd like to just share with you is some design features and just share some of the capability that the SMEC team have in Australia that we can share with obviously our partners across the globe. So I'm going to talk about the surface viaduct and civil, which is referred to as the SVC package. It's on the screen. You can see a viaduct bridge structure which contained the metro network that's spanned over existing roadworks. The package that I actually worked on was the Operation Trains and Systems, the OTS package. That's actually the network, the new metro network, which is referred to as the Northwest Rail Link project, which was 8 stations, 3 underground stations and 3 above ground stations which connected to this viaduct. And then I've just recently finished the Crow's Nest underground station, which was a design for a station platform network. So some of the key features that we want to differentiate between why Sydney Metro have taken up the metro system is Australia hasn't had a metro system, and we know across the world metro systems are are well established, and this is some of the reasons and features that we've introduced for the Sydney Metro rail network. So we'll just talk briefly about rolling stock differences, the track form, slab track and ballasted track configuration that was used. Track alignment and geometrical parameters is critical because we have a new formed train rolling stock that we have to get into tunneling segments and new platform design. Transit space and clearances, derailment containment, some of the techniques we used on this project, and the track structure integration and expansion joints. So basically, we have in Australia 5 modes of transport. The Sydney Light Rail, which is a 10 to 12 towel rolling stock. The Sydney Metro is the one I'm working on, is the 13 to 15 towel. Sydney train passengers, there's 16 to 18. Then we have the Sydney freight trains, 19 to 25 towel. And then the ARTC, it's the heavy haulage for all the coal trains. But the picture that I'm circling with my cursor, hopefully you can see it, is the Sydney Metro 13 to 15 class. The geometrical parameters we had to design for is obviously the kinematric structure is very, very small, and we need to work with very tight tolerances. One of the key features for the Metro is our existing network actually had steps onto our platform. The current design is actually as a leveled platform for safety reasons. We have sliding doors for safety reasons, and we've had to work out the kinematric geometry to make sure that we could fit this train within these very tight parameters. One of the key features that we introduced here in Australia is what we're referring to as the track form. It's a top-down construction. So on the left here, you can actually see the tunnel segment. So the running tunnel is produced. The rail system, we've actually got what we've referred to as a dog bone sleeper. These are precast units that are fabricated off-site, and they allow to be brought fully assembled with the track rail connectors. We actually connect it to the rail, install that into 24 metre lengths so we can bring them in one piece, have the reinforcement already in place, and once it's in place you can see we actually place the concrete in between the track form section, and this is a very, very quick and easy way of installing these track forms. Also too, just a comparison with the track structure comparison table. The side track direct fixes, there's 3 different types, but the basic difference is really with the heavy rail system is that it's a very consolidated system which connects the track, which has to make sure that it doesn't provide any lateral forces. With the new low profile egg, if you can see here on the right, there is a lot of flexibility in connecting this system and allowing, cant design, straight design. The tolerances are quite tight, but we can actually have a lot more flexibility in here to move this in place. And then underneath there, we put an invert slab that locks everything into place, leveled with the track form. So it's a technique that we use. Precast is very commonly used in Australia, and it's a very fast mode of construction. Also too, on the actual track, we used a different system for the viaduct. The structure interaction with the track, we actually consolidated the track form into the top deck, and this allowed for a very nice, neat configuration, because we could build the deck structures off-site had the track already reinforcement connected, and then we could come along and make a connection, which I'll explain a little bit further. So just some general information. It's a 4.4 kilometre long viaduct with station platforms, elevated platforms. We had 3 overbridges because we had a configuration where we had to work above existing road network, and one of the constraints of the project is we couldn't shut down that network, and we had to keep moving and building without any interference with the road network. We used the Type 1 slab track, which I'll show you a little bit later. 39 metre was the average span for our design of our viaduct cable stay arrangement, and we incorporated expansion joints and switches within the structure. Well, another feature we looked at was derailment containment. So this is an existing heavy train configuration that is used for derailment, especially around very curved geometry. So we use this principle, but we came up with a system, whereas you can see here, the system here is a concrete, what we refer to as a concrete form, or concrete derailment curve. So any derailment would be contained within the configuration of the rail system. And obviously you can see the critical design speeds are all designed so that we don't get a derailment, but in case we do, we have these derailment curves designed to prevent any of the derailment to take place. The construction of the SVC package, the services viaduct construction, was a key feature for our design. So SMEC were responsible for the entire design. Again, as I mentioned, predominantly precast concrete structures built off-site. This allowed us to build very accurate segments off-site to have a better quality control, and we can actually bring them via road transport to the site, lift them into position, and then slide them into their final configuration. This is just an aerial view. Like I said, it's approximately 4.4 kilometres in length. This is the cable stay structure zone in here because we had very large road spans. As you can see, we had column configurations, but the road network had to stay open at all times. And this is the very large span. That's where the cable stays were introduced because we had to keep this freeway fully functioning and fully operational. Some of the design challenges we had, this is the configuration that you can see is the end result. And it was this geometry was designed on a curved geometry so that we could miss the road network, which created a lot of issues for the design team, but the constraints we had to design, some of the project performance requirements, which was set by Sydney Metro, was the deflection limit for serviceability limit state under the rail traffic load plus dynamic loading allowance could not exceed a span of, a ratio of the span over 950, which is approximately 130 millimetres, and the other constraint was that the depth of the deck could not be greater than 3.5 metres. So taking these constraints into account, we actually came up with a precast segment to allow, like I said, these segments to be built offside with pre-tensioning. We could connect it, and it allowed us with the cable stay arrangement to have 39 metre spans so that we had no interference with the road below this bridge structure. Some of the key features, that we had to really look into was a cable stay design versus an extrodosed design. Because of the constraints that we had issues with regards to temperature, deflections and expansion. We had height constraints because of there was a pending airport coming into this zone, so we couldn't have really high masts or pylons, and the traditional cable stay bridge has a very thin deck. So the actual configuration that we actually selected is this one in here, which is the extra dozed structure, lower pylon, short stay cable with deep girders. This is a smaller deflection in the daytime, and it allowed us to keep within the constraints of our 130 millimeters for the serviceability scenario. So this also was a constraint that the client put on us, because they wanted to do future expansions, and if they wanted to allow for any flexibility in the future, they didn't want to have a light structure. The one on the left would have been much lighter but a lot more flexible, and would have to have a lot of retrofitting. So to future-proof it, we actually selected this extra dozed because it had more flexibility, and it was a stronger structure moving forward, and it met the client's criteria. The curved horizontal alignment, as you can see, this was the biggest challenge for us, because there's no straight lines. Every curved structure that we had to design, this cable stay, the constraints with the deflection, the geometry around a curved structure, all was one of the challenges that we had to meet. And you know, although this was a rail project, our road partners with the Transport of New South Wales Road Authority were very strong, and had a strong opinion on how we could actually build our structure over their road network. So it created a large challenge, but we were able to meet the challenge, and the only way we could come up with these curved configuration was to have segments, viaduct segments, to allow us to build them in pieces with post-tensioning, and allowed us to connect them in this curved configuration. As I mentioned earlier, this is the track. See here, we actually, as part of the deck structure, we actually installed these U-shaped starter bars that we could actually connect in the configuration with the track, and we had reinforcement that we could actually put the track form and into place, and allowed us to place all the reinforcement with the track. The arrows that we're seeing here is that we had, because of the train and that curvature, we had lateral bending moments that we had to design for, and hence the configuration of this curvature was the best way that we could actually counterbalance the forces in these directions. So, as I said, the key challenges is we had a constraint by the client that 3.5 metre deep box structure in its form was insufficient, and so we had to think of ways that we could actually increase the stiffness of this structure. So the first issue, we had to get the deck to work at the ultimate limit state, to avoid tension in the deck section, so that we could maintain the serviceability limit state. We then had to work out how to limit the transverse moments in the pylon. And then we had a limited on the deflection of the pylon associated with the second order effects, with the expansion and the heat of these. So these were the three challenges that we had to try and work out. So the design team selected, as we said, the extra dosed bridge behaviour. So the stresses, the range of the stresses with the cables were relatively low, because the girder predominantly carries the applied live loads. and then the structure before it struggled with the ultimate limit state because of the imposed rail live loading was carried primarily by the girders. So because we had the deep structure, this is where we allowed the girders to do a lot of the work, and with the cable stays and the short cable stays in this extra dosed configuration, we had to provide some additional strengthening within the actual deck structure to transfer the loads and work within the ultimate limit state limits. So the solution to get more load into the cables was therefore developed by increasing the cable stiffnesses. That is, by increasing their area, the cross-sectional area of these cable stays. So a more conventional alternative would have been to haunch the girders, but that introduced a very difficult construction, because we wanted to have one standard mould that we could actually build in the casting yards, and therefore it would have been it was easier for us to work with the cable stay design and keep the actual bridge deck configuration standardized, so we can improve the speed of construction. So increasing the pylon height was also another alternative, but however, where the limits be placed on us because of the pylon widths meant that the pylon failed in the transverse bending as the height increased. So this is where we needed to make sure that we transferred most of the loads into the actual deck structure. So how did we achieve that? We had to increase the capacity of the box section. So initially our original design looked at what we called a central fin at the top of this section, and then we wanted to introduce a web so that we could increase the torsional stiffness of this structure. So ideally the central web within the concrete fin projecting above the box section was developed, but what we found that when it came to constructing this configuration, it was very difficult to build the central web. So our construction partners did not allow us to, found it very, very difficult to increase that, introduce that web, so we actually had to remove it. So by introducing and strengthening the actual, what we're referring to as the central fin, the precast production requirements ruled out the internal web, as I mentioned. So a reinforced concrete fin section was then introduced above, and as you can see, the centre of balance, centre of gravity allowed this to be symmetrical in our design, and this central fin was all that was required to increase the stiffness of this deck structure. So as you can see, in the casting yard, we had the 3.5 metre depth by 14.7 metre width, and these segments were all built off-site quite accurately with good quality control, and then transported to site into its final position. Reducing the transverse moment in the pylon, the eccentric stay anchorage system was connected, so this allowed a symmetrical connection through the actual cable stays in this rib, where we could anchor our cable stays, and that caused a nice configuration to anchor our cable stays within the actual ductwork. So this is an actual photo. So these are the anchors. See, the cable stays were all connected into these ribs, and this allowed this anchorage to be connected internally, and it actually was a good, clean working environment to allow safe access, and equipment could be installed, and these anchors were tested to the design capacity. Another little exercise that we also did, we wanted to optimize the cables. We actually looked at 4 options. So all cables with 185 strands was considered. We looked at option 2, which was 2 rows of longest cables, 169 strands, and the remaining cables with 127 strands. Option 3, the longest cable of 169 strands next to the cable with 127 strands, remaining with 91 cable strands. And then the longest, option 4, longest cable strands of 169 with 91 remaining. So the configuration we actually adopted was the option 2, was the 8 longest stay cables consist of 169 strands, with the remainder of the stay cables consistent of 120 strands, as illustrated below. And this was the most economical configuration and cost effective once we spoke with the suppliers of this equipment, of these cables, sorry. The last piece of my presentation here is also SMEC were successfully won a station design, an underground station at this point. This is approximately 32 metres below street level. You can see here that this is the temporary works to support the station box configuration, and our job that we won was to actually design the station box configuration internally to this. So this allowed a team to come together. This was a very complicated design because we had not only structural design, we had mechanical design, we had rail track design, we had cable services, we had to interface with the line-wide contractor, we had architectural expertise that we had to come up with a design that would impress the government, and so we had to, SMEC were responsible for really coordinating all these services. So for Crow's Nest, the reason that we actually won this project is that, as you can see on the diagram on the right, this is the configuration of the station box. But what we offered the client is that we actually offered them that we could come up with an enabling design that could take an oversight development, a residential or commercial building. We left that option up to the client, but what we sold to them was that we could actually design the box structure for the rail station, but also design it so that in the future the client could sell the air rights to a potential developer and allow the train station to support I think at this point it was about a 17-story building that we could actually place on top of it. So it was a very good selling feature for the future, and the government, Sydney Metro, actually was impressed with this concept and was really the main reason we actually won the project, because we just were a little bit innovative in our thinking. So the innovation of the engineering outcome was the use of precast concrete for a quicker construction time. When you're building a box, time is always against you. So as you saw in the SVC package presentation earlier, we SMEC have a lot of experience with road bridges and bridge technology. So we actually took some of our smart structural engineers in the bridge group, and we actually got them to design 24-metre spans, bridge decks that we could make off-site and place planks on top of it, and allowed us to have a structural system that we could build off-site and transport these structures the final position, and it was actually fast construction time. So this project we actually only had 2 years to construct and 13 months to design. And so we had to think of quick ways to build this as quickly as possible, and that's where the precast concrete configuration was predominantly the reason for quick construction. Also, the Crow's Nest station was the first underground station to have more than 90% of the precast structural elements. We had precast beams, as I mentioned, precast decks. We actually had precast platforms that could all be built external to the site and transported into position. The actual walls that you can see here are cast in situ. We looked at looking at them in precast, but because of the building OSD structure, we actually couldn't get the loads to work with precast. So that's where the 10% sort of came from, cast in situ walls, which are about 1 metre thick to take the loads above. Also, the proposed stage 1 design had 3 residential oversight development buildings on top of the station box, which meant that the station was difficult to build. So we actually changed the configuration. So we stepped the structure. You can see this step structure. So in the ends of the building, we had back of house configurations, and that had a lot more structure to allow taller segments at the ends. Where the station proper was involved, we actually reduced it. So architecturally, it looked more attractive. The structural system was quite well received, because we had this diaphragm action where the loads would be then transferred via this bracing and take it right down to the walls of the structure. Again, another feature that was easy to build. The spec team then proposed a constructability model approach to prove the proposed design was buildable. And I'll explain what I mean by that. This was a design-only contract, so City Metro wanted to have confidence that what we designed we could build. So we actually developed a 3D modelling environment where we could build this structure in 3D and prove to the client and our team that this design was buildable. So SMEC assembled an experienced team. This is sort of the architectural feature. As you can see, these long spans, these are precast concrete decks based on bridge technology. We actually had precast walls, but with a brick feature. This is one of the design aspects of the Crow's Nest station. It's an old area in Sydney, and we needed to marry in with the existing buildings, and the majority of the existing buildings have terracotta bricks, and so we came up with this design. So the design excellence, why I feature that this was another reason that the client selected us, because of our design excellence in the architectural space, our structural excellence, so that we brought in our bridge engineers to come up with very economical long span designs. We partnered up with an organisation called NDY to bring in the mechanical and electrical design efficiency. Mechanical was done by an external consultant. Electrical design was done by SMEC. Constructability, we looked at our constructability model, and like I said, we could prove that what we designed could be built. We had a very strong focus on planning approval. The local community, we had to make sure that part of the conditions of approval was that the local community would be involved in this design, involved in the stakeholder and feedback, so that we could feature a lot of their feedback and incorporate a lot of their features into the design, so that we could make the local community accept this design moving forward. Also, there was a strong focus on project management and design management. This is the area that I actually specialise in. I was the project manager on this project, and my key success factors was team building workshops with the client. I like to bring in the client and set the strategy at the beginning of the design, so we have the same goal moving forward. And the main issue for the client was budget, obviously, time, and working in a very confined area because we had roads on either side of this underground structure, and so we could not disrupt the local community. From a design delivery, we had a common data environment, which is a 3D model environment and one project office. So we actually brought everybody into one project office. It was the SMEC office in North Sydney, actually. And we had everybody, the client, the consultants, the SMEC team, the management team, all in one office. And this allowed very good communication, it allowed very good team building, and it allowed very positive decisions and focused decisions to be made to allow the design to progress. We used a digital engineering platform for all disciplines to execute their work. We created a common data environment. We had weekly interface meetings, and we virtually built this entire structure in 3D. Like I said, there was an architectural, electrical, mechanical, structural, civil. We had pedestrian modelling, and we all had to make sure that this all fitted with the line-wide equipment that had to be installed as well. So the only way we could guarantee a collaborative design is to do it in a digital engineering platform in 3D. Constructability led, we had a constructability lead, was engaged. So he was responsible for managing the 3D model, which allowed us to, again, prove that we could build this in 3D and guarantee that everything that we designed could fit on site. And we also had weekly leadership meetings, having everybody in one office, the client, the project managers, the design managers, and the discipline leads from all the different parties. We could have weekly meetings, make quick decisions, and move forward. One thing that I'm very proud of this project is the team, we achieved design freeze at the end of stage 1. In Australia, we have a 3-stage approach, stage 1, 2, and 3, concept, detailed design, and final design. This team built this package in this design in 13 months. So like I said, this is part of the Sydney Metro West project. There were 8 stations out of that network, Sydney Metro network. Crow's Nest was the last station to be awarded, and SMEC was the last team to actually win the package, but the first package to get client approval. And so this was, I'm very proud of this achievement, and it was really allowed us to give the client extreme confidence on our ability for station designs. Value engineering was a big feature also for the client. And so the first 2 weeks before we actually started any of our design, we actually had 2 weeks of workshopping and value engineering, bringing in our construction experts, the client's construction experts, our design team, the client's subject matter experts, and we worked together as a team and looked at all the different value adds that we could produce, and which was a big success for us because we could get everything identified within that first 2 weeks, allowed the stage 1 design to be developed, so all the concepts were locked in, At the end of stage 1, we actually got the client's approval and sign off, and then it allowed stage 2 and stage 3 to just do full detailed design with no disruptions. And believe me, that was a big, one of the big success factors. That's why we were able to achieve the total design in 13 months, because the stage 2 and 3, we had no changes. The SMEC team was experienced with design compliance and verification processes. In Australia, we have what we call an AEO, an authorised engineering organisation, which is it's a systems engineering approach, and this allowed we had experienced people knowing what all the compliant requirements was, and a dedicated systems engineering manager making sure that as we developed the design, we actually met all the compliance and provided all the relevant evidence throughout the design process, which was also another main feature, that when we got client approval, we had all the compliance requirements finalised as well. The design of the Crow's Nest station was delivered on time, with each milestone achieved and the cost allowance budgeting under target cost estimates. Because of the value engineering we were done early in the piece, we had quantity surveyors on the team, and our design was constantly reviewed by the cost estimators. So as we felt certain areas were going over the budget, we could then stop, have a look at where those costs were going high, and then we could redesign it, and allowed us to keep the costs within the budget, which was another success factor for us. Like I said, digital engineering was an integral part, fully integrated design solutions, weekly meetings, fully integrated as we progressed to the final solution. Constructability model was used to inform the detailed design, but also verify the construction staging. Sustainability is a big target for us, and this design we were able to achieve a 6-star Green Star rating from the Green Building Council of Australia. The target was 5, we were able to achieve 6. Again, we were very, very proud of that achievement. The design team also provided sufficient information to Sydney Metro's environmental planning team to achieve planning approvals, which was really allowed the actual OSD, the oversight development, to be part of that program, part of that approval. So we actually got the station design approved, but the airspace above it approved with the same approval, which is a very good selling feature for the future. So I've been talking about this for about 5-10 minutes, this constructability model. So here you can see we had a separate model, and what we did is we actually positioned the cranes. We did a crane study. This is the Pacific Highway, as you can see my cursor. This was one of the constraints, that we were not allowed to stop any activities of the roadworks. So that's the reason why everything you can see on this diagram was with beams and precast slabs, all built off-site, transported at night, picked up by our 350-ton cranes and positioned in place. And you can see these pumps. We actually could simulate the actual pumps, making sure that we could position temporary decking, allowed concrete pumping of the walls, and all the different sequencing. We made sure that we could get it off the back of a truck, get it into position, and we proved to ourselves that it was actually totally buildable. The other, one of the major requirements for the client was interface management. So we actually engaged a independent interface manager, and this person's job was, sole responsibility was to look at the detailed interface specifications. So the client provided specifications on how we needed to interface with Linewide being the track supplier, the communications, all the cables, all the ULXs, All this was being built by Limewide, but we had to interface with that contractor, all the electrical equipment, all the high voltage cables, all that had to be interfaced with our structure. And so we had a dedicated interface manager that could work with our team and the client's team and the interface contractor Limewide so that we would have an integrated team. The equipment schedule, Limewide would have a bunch of equipment, like I said, track, electrical kiosks, control rooms, a whole bunch of mechanical and electrical equipment that we had to make sure our structure had all the penetrations to allow all the cables to be coordinated into that design. We had the MTR room data sheets and matrix. Again, these were all the design parameters that the Limewide contractor needed to make sure that the equipment that they needed, our structure could take the weight, penetrations, etc. We had to produce interface drawings and get that signed off by the client and the Limewide contractor to prove that our design and their interface with their equipment was key, and we could sign off that it would work. So the only way we could make this work is through our DE, our digital engineering framework, a federated model. Every week we federated a model with all disciplines, including line-wide. This was a very, very complicated exercise, but the only way we could integrate all the mechanical, electrical, structural equipment supply was in the 3D modeling environment, and run not by a digital engineering person, but by an engineering manager, someone that actually understood how the design and how it had to be built in a 3D modeling environment, and bringing all the right disciplines together, solving problems and coordinating the design. And that's it from me. So I hope that I gave you a little bit of a snapshot of what we could actually, the experience we had at SMEC. Like I said, this is a part of a 61-kilometre network, rail network. It had viaducts, it has underground stations, it has above-ground stations. So this network is now into its third phase, going out to the west. And so I'm hoping that I gave you a bit of insight on some of the expertise that we had. So,
okay, thank you.
So,
yeah, thank you, Chef. It's really a comprehensive presentation. It's more on structural engineering side. Yeah, we learn a lot about the type of bridges, talking about the cable stay bridge and so on. And we also learn about the innovative engineering design that you have shown in your slides, as well as the constructability approach that you did on the project to ensure that the project can be met on time, on cost and on quality, of course. Okay, we have two questions from the participants. It is actually in the room chat. The first question from Yasa Gunadi. Is the interior of 3.5 meter concrete box accessible for regular inspection during operation? That's
yes, good question.
Yeah.
Sorry?
Yeah, the second question is how much efficiency can be obtained with the innovation of accelerating precast concrete construction compared to conventional construction method?
Okay, first question, yes, with the viaducts we had man access openings to allow for regular inspections. We actually used that during construction because we had to not only look at the deflection limits outside, we also had to check the deflection limits inside because of the temperature differential. So we actually have manhole, and those manholes were remained and there for future inspections, obviously checking the stresses on the cables and any future inspections of concrete cracking, condition assessments, etc., etc. So yes, we did incorporate that. Second question in relation to precast concrete design versus the conventional cast in situ. We believe that we actually saved up to about 3.5 months from conventional design. The main reason is that in our station design, we had to get the line-wide contractor. So at the bottom, we had to open up the construction face to allow the track to be built. And so if we did a concrete floor above the platform where the track was to be built, it would be full of formwork, and it would have blocked all the access for the next contractor to come on board. So by putting precast concrete, which we could build off-site, while the walls were being built cast in situ, we had to build 64 precast units off-site. So as soon as the walls were ready and completed, we could then start to install what we call level 3 beams, and we could pour the precast planks above that level, which meant no formwork, no propping, no interference with the next contractor. So as we built level 3 and moved up for the building of the station, the contractor below could start working with no interference. So that saved us 3.5 months for the station. Also, for the viaduct, the precast units that we had to build, if we were to formwork and do a cast in situ over an existing road network, we would block off the road network. We would create a lot of traffic in Sydney, which was not an option. So therefore, by using the precast, we built the pylons cast in situ with no interference with the road network, and then we could then build all these viaduct precast beams, deck sections, transport them off the back of a truck, lift them into position, and with no interference to the road. Yes, we have a question. There's a hand raised, Habibi.
Yes, I think I will give one more opportunity to the participant. We have Dr. Ayudin would like to raise a question. Please, Pak Ayudin.
Yeah, thank you very much. Previously, I would like to thank the keynote speaker, Mr. Insinyur Habibi Rasad, who gave me the opportunity to ask questions about railway construction. Then, allow me to ask, first, I would like to introduce myself. My name is Yudin. I am a civil engineering professional board of the Indonesian Engineers Association, and I am a lecturer at Makassar State University. In the world of soil construction is one of the problems. We know that, especially in making a strong foundation. The soil has a low bearing capacity, so that a decrease can occur if there is a shock load of excessive tread a vehicle bend pass. The subgrade must be able to support the force generated by the train. Of course, there is a vertical force and there is a horizontal force. My question, how to anticipate the strength of the railroad track with in a stable ground condition? Is there a foundation model that is suitable for the condition? Thank you, Mr. Isnur Habibi Rasad.
Okay, Staff, can you understand the question?
Yeah, so your concern, your question is how would we analyze the ground conditions if our track design was onto a subsoil sort of environment. So the metro. So what we do here, we have a very big geotechnical team, part of SMEC. So we would come in and we would do extensive geotechnical analysis. We would take a lot of geotechnical data. We would analyze that data through we have software called Leapfrog. It's like a finite element analysis package. Based on the information that we actually get from the site, we actually build a 3D modeling environment. We apply the lateral, horizontal, and vertical forces, and we look at the interaction of our tunnel. So we have a running tunnel, which has to be. We have a tunnel boring machine, and we go through that area, and we look at that interaction with the tunnel. We then look at the station box. As you can see in my last couple of slides, we had a 32 meter hole that we had to, we used an anchor design so that we could stabilize the vertical walls with anchors and secant piles, so we could stabilize the walls, and we would do exactly the same on the ground. In Australia, we're quite fortunate because the majority of our subsoil in Sydney is on sandstone. So we have a very strong subgrade. If it was in a soft soil, we have a specialist, one of our geotechnical, his name escapes me, who is a soft soil specialist. So what we would do in that scenario, we would use water would be a big issue if we had soft soils. So we would use a tension pile type configuration with ground treatment, and we would strengthen the sub-base in a soft soil environment so that we would get the bearing capacity that we require and make sure that the settlement was within acceptable limits. And then we would build our bench, our concrete structure, and then our rail system on top of that. But most of my experience is in sandstone, so I'm quite fortunate that my material, the subgrade material in Australia is quite robust.
Okay, thank you.
Okay.
Pleasure.
I think, all questions have been answered. I believe still many participants would like to raise questions. We are just limited by the time also. The organizing committee and steering committee here already informed us that the session for this international symposium already ended, yeah. And then I think we can just pass it over to steering committee, Pak Ilham, to close the session. The MC, sorry, the MC.
Silakan, Dek. Where is the MC? Hello.
Where is the MC?
Okay. Seems the MC is busy. Okay, ya Pak Yudin, raise hand-nya udah bisa down. Okay, thank you Saf for the last speaker. We hang on until the last minute of our international symposium. Thank you for all the questions and response and comments. Thank you very much. We appreciate the involvement during our symposium. Allow me to express our thanks to all the speakers before it is being closed by the Vice Dean for Academics of Faculty of Engineering. Let me just share my screen with with the thank you of all the speakers. We have the certificates. I hope it can be shown in there. Is it shown in the screen? Yes? Not yet, or shown already?
Only my photo shown in the screen.
Not yet. Hello everyone. It should be shown by now. Okay, I stop sharing and do it again. Oh yeah, it's already done actually. All right, yeah, okay. So ladies and gentlemen, on behalf of the committee as a chairman of the International Symposium, I would like to convey the token of appreciation to all of our speakers, from Mr. Daisuke Nanjo and Pak Hermanto, thank you very much. And Prof, it's not showing. Is it? I don't know. Can you see my screen? No?
No, it's not showing.
Not shown? Why? What happened?
No.
Oh, maybe Saf still showing. Can you stop sharing, Saf?
Okay, yes, I can do that. Sorry.
Tadi kan masih Saf yang share ya. Yes, now you can see my screen. Yes, thank you very much.
Yeah, sorry about that. Thank you.
No problem, Saf. Thank you very much for all your involvement in our symposium. So allow me to share once again the certificates before it's being closed by the Vice Dean. This is our token of appreciation to our speakers, to Mr. Daisuke Nanjo, to Mr. Hermanto, to Pak Wali, Prof. Pak Dani Pomanto, Pak Umar, and then Pak Yomil, thank you very much. And also Pak Zulfikri, who is represented by Pak Harno. And then we have Pak Jumardi, terima kasih Pak. Sertifikatnya nanti kami kirim juga ke Pak Mardi. And Professor Mr. Mitsukage Yamada, thank you for your time. And then we have Karen Saf. And then also, lastly, we have Karen Atkinson as Pak William Sabandar. And mostly to our moderator, yeah? Pak Habibi Razak and of course Prof. Isran Ramli for all the dedication given to us to lead the session from session 1 until session 2. Thank you once again to everyone, all the participants. According to registration, we have 250 registered. But during the Zoom meeting, we reached until 250 yeah, this morning. Thank you very much for all your participation. As the chairman of the committee, I would like to also apologize for the connection sometimes or everything that is misleads in this symposium. Finally, I would like to hand over to Professor Baharuddin Hamzah, the Vice Dean for Academics of our faculty, to officially close this international symposium. Silakan, Prof.
Ya. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon and maybe good evening now in Australia, Sydney and Brisbane. On behalf of the Dean of the Faculty of Engineering, I would like to, first of all, thanks to all the speakers for this, the second AVI International Symposium. which is we have 5 speakers in the morning, and then we have another 6 speakers in afternoon session. And also, thanks to the moderators. Yeah, we have 2 moderators, Senior Habibi Rasak and also Professor Muhammad Isran Ramli, yeah, for leading this symposium. Okay, I think I follow almost the rest of the symposium, and then it's very interesting to talk about this, about the transportation, especially for the railway, yeah. And also, of course, we hope that we have a meaningful result from here, and then we can apply in Makassar or maybe in South Sulawesi. Yeah. So again, thanks very much for all the speakers and the moderators, and of course the organizing committee and all participants to make this symposium successful. Yeah. If we see the participants, we are more than 250. So means all the participants, I think, have a good contribution, and also is the indication of the successful of this symposium. Okay, so finally we now at the end, and then we have in the closing ceremony. So with Alhamdulillah Rabbil Alamin, I officially close this symposium. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Waalaikumsalam warahmatullahi wabarakatuh.
MC, please take over. Udah. Ya, oke. Silakan, Dek.
Okay. Thank you very much for the Vice Dean of Student Affairs, Research and Innovation Engineering Faculty of Universitas Hasanuddin to have officially closed the second EBI International Symposium on Railway Technology and Development 2021.
Ladies and gentlemen, that's all of our agenda today of this International Symposium 2021. As the Master of Ceremony, from the deepest of our heart, we do apologize for any mistakes during the presenting of this ceremony. Thank you very much for your attention, and see you on the next conference. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Thank you very much.
Thank you.
Sampai jumpa.
Thanks, everyone. Bye.
5, 4, 3, 2, 1. We start in 5, 4, 3, 2, 1. 5, 4, 3, 2, 1.